Sometimes the major thing that completing a degree or going through a DATATHON can give you, and that employers look for, and we've done research, is your ability to complete it, your ability to stay the course. Because it's as hard, because the data is amazing and I love it, as you've heard through this week. And the computer science is fantastic. But none of that really helps unless you can actually produce a product and finish the project. We do data management planning, but data management planning is a version of project planning. And what I'm going to introduce to you is the head of project planning and the person who understands what it takes to take the lovely raw data and the interesting ideas to completion and to actually a product. And I think he's in the room now. And would you like to start? And you might be interested to know that he began his career in the Department of Defense, I believe as a soldier. So perhaps you don't want to annoy him. And would you like to go?
Yes, thanks, Nina. Thank you, Chair. Good morning to everyone. It is indeed an honor for me to do this part. Mine is only to welcome you to this, on behalf of the research team. I would like to welcome you all to this last and final day of the third DATATHON competition. So our student teams have worked tirelessly over the past 4 days, despite the current COVID-19 challenges and ongoing exams to some of our students. We thank you all for all your hard work. And also special thanks goes to NFARM, who made it possible for us to meet virtually and providing this online platform. We are truly grateful. A little bit of DATATHON overview. Like I said, this is a third DATATHON student competition, and it's a second which is held online. We just completed the last one, which we couldn't hold in 2020 due to COVID-19, but we're able to hold it in 2021, just a few months ago. The intent of DATATHON, briefly, is to equip high school students as well as university students with skills and to expose them to data skills, including data analysis, cleaning, and so forth, in order to produce solutions in resolving real South African problems. So DATATHON is a platform where the students get opportunity to showcase their solutions for them to be judged as per predefined rules. The plans have also been put in place for the winning teams to participate further on the international data competitions. Now I will share with you our teams. If I can just be able to project. I hope that you are able to see my screen. Yes. So in this year's competition, we have a privilege to have about 9 student teams, which are coming to about 7 of the 9 provinces in South Africa. It shows the spread of this competition to the entire of South Africa. So we've got teams from Rhodes University, which call themselves Purple Code. We've got Val University, Ethical Team Innovators, TUT, Patent Pros, UJ, Code Fellas. I don't know where you come up with these names. University of Zululand, Innovatables, University of KwaZulu-Natal, Explorers, University of Limpopo, UL Phoenix, University of Mpumalanga, Orions, and Solplaiki University, Shodan. So you can see the the spread of the provinces where these teams are coming from. It's only 2 provinces where we've got more than 1 team, which is Gauteng and KZN. In other provinces, we've got 1 team in that province. Next, to take note for our teams is to look at the final presentation schedule for today. From 9:30 to 11:10, here in the main room, these universities on the left will be doing their final presentation. It's UJ, Rhodes, UKZN, University of Mpumalanga, and Val University of Technology. And then from 11:20 to 20 to 1, here in the main room, we'll continue with TUT, Solplaik University, and University of Zululand, as well as University of Limpopo. Now introducing our judges. I believe these judges have got a difficult task to do, and I don't envy them because I think it will be a difficult task to do because our students have been brilliant in putting together their solutions, which will make the task a little bit tough for our judges. So first, on our judges, we've got Dr. Simo Mtetwa, who is a lecturer in University of KwaZulu-Natal. We've also got Mpuseli Ntukwane, who is the Vice President of Data Science and the APSA Group's Internal Audit. Kutasha Ntwaitsile, who is a PhD student at the University of Hertfordshire in UK. And we also got Noluvuyo Gatu, founder at Kotungwana, who was also our keynote speaker. I'm not sure how it happened. I just got muted. So the details or the bios of all these judges, you can be able to see them on the website, and you'll be able to see they really achieved so much in their lives. So hence, we've put them to do this task of judging our teams. And coming to our sponsor for this competition, it's really a difficult and a challenging task to organize and host such an event such as the DATATHON, and it requires a lot of time, effort, and resources. And it would have been difficult or even impossible to host or to have such a competition without our sponsor. We are therefore grateful to our sole sponsor for this year's competition. So we thank IBM, represented by Dr. Ismail Akalwaya, enabling us to fund the prizes for this competition. And the details of the prizes that will be won by the teams will be discussed or will be shared with the teams during the award ceremony. With your permission, Chair, I would like to go quickly through the bio of Dr. Ismail Akalwaya. Dr. Ismail is a research scientist at the IBM Research. He's also an Africa and visiting lecturer in the Department of Computer Science and Applied Mathematics in the University of Wits. His 2 main parallel research interests include AI and quantum computing, with the intersection of the 2 forming and tantalizing nascent third direction. Big words. Prior to joining IBM, his career trajectory took him through the Center of High Performance Computing, which is CHPC, as a result, as a research scientist, and the University of Johannesburg as an applied mathematics lecturer. Dr. Akalwaya obtained a BSc in mathematics, physics, and computer science in 2003, and BSc Honors Mathematics of Computer Science with Physics in 2004 from the University of Cape Town. He then joined Quantum Research Group at the UKZN for the Master of Science in Theoretical Physics, covering quantum computing and information. He was awarded cum laude with S2A3 bronze medal in 2006. In 2007, Dr. Akalaya was awarded a one-year Canon Collins Rampele Scholarship at the Center for Quantum Computation, Department of Applied Mathematics and Theoretical Physics at the University of Cambridge in UK. In 2014, he completed his PhD in Theoretical Physics, Classical Noise in Quantum Systems at the University of KwaZulu-Natal. Dr. Akalaya has co-published 9 papers and 10 patents and is a certified IBM Q ambassador. KISS-KIT advocate, professional physicist, and a member of the South African Institute of Physics. We are truly grateful, Dr. Akalaya, for the sponsorship that we received from IBM. I'll now hand over to the chair to guide us through the program for today. Thank you so much. I'll stop sharing. I'm not sure if the chair is still here. I'm handing over to you, Chair.
I don't think she's here. I think Dr. Akalaya can go ahead.
Okay, thanks, Nombele. You can go ahead, Dr. Akalaya.
Can you see me? Can you hear me? Hello, everybody.
Yes.
Good morning.
Yes, I can hear you.
Yes, that's the first time anyone has read out my bio, and it was super embarrassing. Sorry. I'm still I still feel like a young researcher, and my main message there to the students is research is fun. It's a lot of fun, and you should approach it as such, so that you enjoy your work, but all the time thinking about the massive impact that you can have. I mean, so as you know, we live in a technological world, and it's imperative that South Africa keeps up with this technological revolution and becomes a player in this new economy. As you know, with AI and quantum computing coming along, it's set to revolutionize the way the world works and interacts and does science. So we really need to, both, you should do it for the love of it, for the enjoyment, for the curiosity, because it really is amazing. I mean, right down from the philosophical questions about what does quantum mechanics mean to the big questions about can AI be conscious. You know, all these big questions are part of the field that we find ourselves in. And there's philosophical questions, and then there's practical realities about how it changes the world. Self-driving cars, set to really disrupt the transport industry, for example. So my little bio there should rather tell you about this journey that I've been on. I could never have planned it. I mean, it's a decade-long. I picked quantum computing just for the love of it, for the pure curiosity about what it all means. Unbeknownst to me, I would join IBM in 2016, and then IBM went big with quantum. We put the quantum computer on the cloud. And when I first joined the lab, I joined to work on classical AI. But that same year, IBM announced the quantum computer in the cloud, and my local team was so supportive. They allowed me to also do research on quantum, because that's my PhD background. So you can see how it all just came together in a way that I could never have planned. So driven by curiosity and then by the impact, the applications of AI and quantum. That's what I'd like you to take from the bio. About my presentation, I only have 15 minutes, so just so there's no chair. I was going to ask for confirmation about my time slot. Can I continue for 15 minutes till 9:30? Is that, if anyone knows, I can.
Yes.
Yes. Okay. Great. So, in my presentation, I thought I would. So we're sponsoring this competition, and it's a real honor for us. What's our reason for sponsoring this? Well, we want to, like I mentioned, this is so important for the future of the country. We want to get the youth excited. We want to support and encourage research pursuits, this high-end, high-tech, cutting-edge engagement with. We don't want to just be consumers. We don't want to just, in South Africa. I'm South African, born here, grew up here, proudly South African. We don't want to just, tag along with the world and be. One of the worst things about how we could continue in terms of the structuring of our economy is we could be, just consumers, and we could just export our raw natural resources. God has blessed us with such wonderful natural resources in this country, mineral and agricultural and animal life and human, of course, the human potential. We have really brilliant people in this lab. I get to work with brilliant local South Africans. So we have all this potential. But imagine if our economy is just based on exporting raw natural resources. That would be just a terrible waste of all our potential. And that reminds me of a tweet that I recently saw from a professor who was returning from Mozambique, and he in the tweet he filmed the this traffic jam of 5 kilometers of massive trucks transporting raw chrome ore. So basically, what we did was we just dug the sand, dug the soil out of the ground, put it into these trucks, and we were driving them to the Mozambican port for export, probably to China or something like that. So he was, in his tweet, he said, this is such a shame for this country, because we used to smelt our own ore and turn it into at least the refined metals, and then exploit that at a higher profit. Or we would, even better than that, is to then have manufacturing plants in the country that then beneficiate the natural resources even further. So 5 kilometers, he was filming this while he was driving, 5 kilometers of, it just is so painful for me to see that, because that's our potential wasted. So that's really why I think we should supercharge our research efforts. We want to become a global player in this technology age, right? So we sponsored this event because this is what this competition is set out to achieve, is to inspire the youth to apply their minds in this new AI context. And it also fits in very nicely to 2 strands of research that I'd like to share with you that is currently taking place at IBM Research right here in South Africa. I want you guys to be so proud that we as South Africans are making contributions to these 2 fields that are cutting edge, and big contributions, not trivial contributions. We really are making huge contributions. So that's the purpose of my talk. Let me share my slides. Can you see my screen?
Yes, we can.
Cool. So I only have 15 minutes. So I only made 5 slides. Hopefully I can capture the spirit of what I'm trying to say. I need to go full screen. Oh no, that didn't help. You guys are seeing which screen can you see?
CHPC data.
I mean, can you see this, the speaker's notes one or the main slide?
The main slide.
Oh, good. So that's working. So it's not just the one with two, the one with two slides broken. Is it just one big slide or two slides?
Yes, the one.
Okay, great. So you've seen the right slide. Okay, so let me begin. Before I want to tell you a little about the lead up to let me understand correctly this competition. You were tasked, the students were tasked with using any open source data set. Is that correct? For any AI, so apply AI to any open data sets to produce something useful. That was the task, right? That's the competition. Am I right?
Yes.
Good. So it's quite an open-ended task. There was no specific data set except open source, and there was no specific AI tools, if I understand correctly. So I can't wait to see what you guys came up with. So well done. But let me get this right. Do you agree that when you were applying your AI tools, it was quite difficult to just so as you know, there are three main branches of AI: supervised learning, unsupervised learning, and reinforcement learning. I'll just call it that, right? For three branches of classical AI: supervised, unsupervised, and reinforcement, right? And the least developed of the three is unsupervised learning, because we haven't, the research community, the whole industry hasn't stumbled across a good framework for unsupervised learning. Supervised learning, the framework that works amazingly well, as you all know, is neural networks, right? Deep learning, tremendous progress. We've had spectacular successes in the form of GPT, for example, able to, with just prompting, write essays and that are eloquent and sensible and connected to the theme and so on. So translation, visual recognition, neural networks have performed spectacularly well, but that's only in the supervised context and in the narrow one task, one domain context. So you guys would have had that problem. You would have had that difficulty. You have nice data sets at your disposal, but you would have struggled at the beginning, finding, especially if these data sets are just raw data, you would have struggled in knowing what should be your label, your supervisory label that you want to predict. And the good students amongst you would have spent a lot of time exploring the data set before you decided which AI to apply and which solution to solve and so on. So I hope to see that coming through. That exploration phase is actually you doing an unsupervised learning. You just, because you have a background of all that you've learned, and you were bringing your intelligence to just analyze in an open-ended kind of way the data sets. And that's great, and I hope you did well. But even that we need to bring AI to the table. The goal is to have intelligent, unsupervised learning, where you could just release your AI onto the data set without telling it what is the label, without telling it what structure there is there, without even maybe doing cleanup. As you know, in data science, a large chunk of your hard work is in prepping the data, cleaning it, making sure it's good quality, and so on. So there's a big gap in AI research right now for unsupervised learning, and one that involves reasoning. So AI right now can't do reasoning very well. We had the two phases of AI research: the classical logical phase, and that didn't succeed very well. And then we had the winter of AI, and then we had neural networks shining. But the neural networks haven't replaced the classical logic. They've just done spectacularly well on certain domains. So classical logic is still an open question. How do you do logic properly in an AI context? Or how do you merge AI with neural networks with logic? That's a big open question. No one has solved that yet. And you'll be very happy to know that here in the South Africa lab, we are working on that, and we made great progress, praise God. So you get the context. I'm so glad we're sponsoring the DATATHON competition because it's exactly, you guys would have had a taste for how difficult it is to apply AI, first in an unsupervised context, and then you said, no, let me explore it. And then finally, you guys came up with a supervised context. I'm guessing. I can't wait to see what you guys have come up with. Okay, so what I've laid the groundwork for here is that unsupervised learning is just not there yet. It's cutting edge research. We still need to make progress. And what would you expect out of an unsupervised algorithm? You'd expect something like, this is how the data set is structured. You know, there's some patterns that the unsupervised algorithm will tell you. Like, we have some tools, like for example, k-means clustering. It'll tell you don't know anything about the data. You run the k-means algorithm, and then it tells you, guess what? The data comes in clusters. That's unsupervised learning. You've learned something without training a supervised algorithm. So that's an example. I want you to keep that example in your head, clustering. But as you know, it's not very powerful. It's not very robust. There's so many parameters to tune, and the human has to be involved all the time, which is fine. We don't want to replace the human, but more of the work falls on the human than on the AI. So what would a good unsupervised algorithm do for you? It would tell you about patterns without being prompted. One of the ideal things it could do is it would explain the data. It would provide you with an equation to say, forget the terabytes of data that you had to record, that has been recorded, that's captured. Forget the data. This whole data set can be replaced by one equation. And we have a lovely example of that in the history of science, namely the orbit of Mars, right? So there's a famous astronomer who meticulously recorded the location and the time over years, and made published books on this. He was a data collector, and then along came another scientist, Kepler, who took that data set and applied his mind in a creative way and said, hang on, all of this can be summarized by just 3 laws. That's Kepler's laws. Kepler, the famous Johannes Kepler, astronomer, physicist, he replaced the data set with just 3 laws, Kepler's laws. In the end, what it's doing, it's basically the physics of orbits. But he didn't complete the story. Isaac Newton came later again and took the 3 laws and said, I can replace it with just even simpler set of laws, and we can derive Kepler's laws from that. Of course, it's Newton's 3 laws and gravity, the law of gravity. So you can derive, you can explain the Kepler's laws, and then Kepler's laws explain the data set. So that would be the ideal unsupervised learning paradigm. You give the algorithm the orbit of the raw data set of Mars, and it says, hang on, there's a pattern here. These are ellipses. That would be the ideal. So, but we'll be far away from that. But notice, in order to do that, Kepler had to reason. He had to hypothesize. He had to do the scientific method, basically. So that would be another example of what a good outcome for AI, unsupervised AI, is extracting the equations that explain the data. Another good output would be anomaly detection. So you'd say, this is my typical data behavior. Imagine a factory data set, how the factory machines work and so on, temperature, pressure, speed, and so on. And then you say, this is normal operation. And then the AI on its own, without being trained, without the label of now the factory is not working, would say, hang on, the behavior has switched into a different regime. That's called anomaly detection. So I'm just giving you 2 examples of unsupervised learning, and it's so hard because it involves reasoning, and reasoning hasn't been cracked yet, and it doesn't involve labels. So now I'm going to give you 2 techniques that we at the South Africa lab have been working on. The one is quantum machine learning, so bringing quantum computing to the task of analyzing data. And in particular, I've picked this out. There are many quantum machine learning algorithms. One of them is called topological data analysis, which is about the shape of data. Remember, I talked about clustering, and I remember I talked about change in behavior. So regime change. in the behavior. This tool would be great at that. This tool is not about reasoning. This tool is about types of behavior that you observe in an unsupervised fashion. You would just unleash this tool on a data set, a raw data set, and then you'll see what comes out. And here you can see some of the, can you see my mouse? Anybody say something?
Yes, we can. It's 9:30, Dr.
Yes.
Akalwa.
So let me summarize here.
Okay.
So here's raw data, and then this algorithm connects the dots and then tells you about the structure, the geometric structure. But it doesn't have to apply to only three-dimensional data. It can apply to even high, abstract data, high-dimensional data. So this is the classical algorithm. It's about the shape of data, and you can use it to get high order correlations, unsupervised AI clustering, anomaly detection. And this is how long it takes. It takes very long to run. And then right in our lab, we took a famous quantum algorithm that takes very long. I'll draw your attention to the paper here. It takes order n squared depth, and we made it order n. So that's quite a big breakthrough in this field. Finally, that's a quantum algorithm. And let me tell you about our neurosymbolic effects. So the idea here is to combine reasoning with neural networks, because neural networks are very powerful, but they can't do reasoning. So how do you do it? You combine it with logic, classical logic. It's like this here, this bottom map here. Each neuron is a logical operation. And then you can reason in a neural network kind of way. So we're thinking of, here's an example, rule learning to create the logic from the raw data. Here are the orbits, and we'd like to extract the equations. So that's one. We've shown that we can do rule learning with our logical neural networks. And you can also do question answer. So you consume a data set about the world in a logical, this is about a logical data set, not just raw data. And you can ask it a question, and you can get answers in an open world form. That's very new. That's very hard for old tools to do it in an open world way. Meaning, we track what is unknown. In logic, you only have true or false. But what if you don't know the answer? So we now have a way to track. We don't know the answer, and then we also have this downward inference as a new mechanism. And I'm so proud to use this occasion. I'll stop now. To use this occasion to announce the open sourcing of our LNN, brand new. This is hot off the press. This conference can be the first place where we announce the open sourcing of LNN, and I invite you to go and have a look at it and see if it tickles your fancy as a field of research. After after wherever you are in your research career, you could consider doing a master's or a PhD in this and working with us. So that's what I would invite you all to do. Thank you so much. Thank you for the time. Congratulations to everyone who did well and who applied them. Okay, congratulations to everyone for applying yourselves, and then well done to those who succeeded and win the competition. I think I am involved a bit later on as well, so I get to see who the winner was. But thank you for allowing us to be a part of this, and we're very proud to sponsor this award. Be proud that here in South Africa we have an IBM research lab here in Bloemfontein. I'm at the lab now in Bloemfontein, Johannesburg. We're part of the WITS precinct. We have ongoing collaborations. We want to work with scientists in the entire country. We want people to learn about quantum computing. We have premium access to the quantum computer. WITS has premium access. They're paying for it, and they're so generously sharing it with the Arua universities. We want we'd love you guys to start using this quantum computer and the open sourcing of our latest breakthrough in neurosymbolic AI. Thank you so much. Let me pass back to the chair.
Thank you, Dr. Ismail. I think our chair is disconnected or having load shedding, so we will just continue with the program. So based on the order of presentations, we are going to be starting with UJ. But before we do that, I just want to confirm, Dr. Mthethwa, that you are ready.
Yes, no, well, I'm ready.
Kushata, you are ready?
Yes, I'm ready.
Noluvuyo, are you ready?
Yes, I'm ready.
And Nkuseli, are you ready?
Ready from my side.
All right, thank you. So you can just use the provided templates for each of the teams. So we will start with UJ. So one of their members is unable to present, but since they did a pre-recording, we will just ask that the pre-recording be played for us. Webcast team.
Good morning, everyone. We are Team UJ, also known as the Code Fellas. Our team consists of Sean, the team lead, Aman, Osman, and me, Abdurrahman Ali. In the pursuit of attaining quality education as a collective, it is imperative that we achieve equal access to technical, vocational, and higher education. This would ideally break the cycle of illiteracy, poverty, and reduce the overall income inequality.
There are discrepancies in the accessibility of tertiary education institutions amongst the various ethnicities in South Africa. The objective of this project was to analyze the trends, forecast the future estimated enrollment rates, and to provide key insights to uncover any possible biases in the university enrollments.
Our methodology goes as follows. Firstly, we find and retrieve the public data from various sources. Secondly, learn the tools that we will use to process the data, for example, Flask and Angular. Thirdly, we explore the data and analyze it, exploratory data analysis, EDA. Fourthly, we clean and prepare the data and separate it into useful data. We train the machine learning systems models using the clean data, develop a dashboard for the web application, and we make an API. At the fourth step, we integrate the back end with the machine learning model and integrate the front end with the back end, and lastly, we analyze the data from the user interface.
The main sources for our database come from the following databases: Spreadsheet, SA Demographics, Census, Stats SA Publications, Open Africa/Zenodo, and the Department of Higher Education. With regards to data preparation, we've done the following. Spreadsheet formatting of data had to be cleaned and undergo structural changes in order to represent data that had several dimensions. Teresa members helped in this regard and suggested something called one-hot encoding. We specifically filtered for the subset of people who are of appropriate age for enrollment. We also used SciPy's interpolate function to make up for sparse census data, to align enrollment data with population densities over the years. Included in our data preparation was training and evaluating metrics of our machine learning models. Lastly, comparing and finally deploying our models in the back end.
Challenges we faced as a team were stressful and frustrating. Firstly, finding datasets for our idea was very difficult, as finding accurate enrollment information broken down to the different ethnic groups for every university is challenging. Secondly, after preparing the tedious and difficult data and initial data evaluations, making the models were extremely challenging, as none of us have had any experience with machine learning, nor Python. The next big challenge was after we began coding and realized our choice of tech stack was inherently flawed. We had to change our Node.js backend to a Flask backend after struggling for hours on end trying to force Node to communicate with the model. Lastly, integrating everything and testing all the data, UI and visualizations were challenging as well.
Hi, webcast team. There seems to be an echo on the video.
Added value. Trends of enrollments is made available and digestible. Estimated future enrollments is
Hello.
I'm wondering if webcast support isn't supposed to be muted while playing the video. I think that's why there's a constant echo, because the mic picks up what is being played as well.
Oh, okay.
I think there's a way of setting the sound to still work when you play video, but I know in the past I had to mute myself while doing that. Otherwise, there's an echo.
Okay. Could we try that and fun? Hello.
Screen, and when you click on share screen, you'll see on that screen in the left hand corner there is a block that says share sound. So you select that one and then you mute yourself.
Yes.
Yes, but you should mute yourself as well.
Let me just
Good morning,
try
everyone.
on my side.
We are Team UJ, also known as the code realized our.
Yeah, there's no echo on my side. I'll play it on my side. It's fine. Can you see the video? Are you able to see the video?
Yes, no, but it's not full screen though.
Is it fine?
Yes, and now you should just mute yourself, and when you share it, just remember to select the that you click the share sound when you selected share screen.
Okay, let me start over the sharing. Share screen.
And then you'll see in the left corner it says share sound. So you should click that one, and then you can, I think it will work then if you mute yourself and then play the video.
Okay, share sound. All right.
I'll say in the chat if it
Okay.
works.
Thanks, Marie.
Good morning, everyone. We are Team UJ, also known as the Code Fellas. Our team consists of Sean, the team lead, Aman, Osman, and me, Abdurrahman Ali. In the pursuit of attaining quality education as a collective, it is imperative that we achieve equal access to technical, vocational, and higher education. This would ideally break the cycle of illiteracy, poverty, and reduce the overall income inequality.
There are discrepancies in the accessibility of tertiary education institutions amongst the various ethnicities in South Africa. The objective of this project was to analyze the trends, forecast the future estimated enrollment rates, and to provide key insights to uncover any possible biases in the university enrollments.
Our methodology goes as follows. Firstly, we find and retrieve the public data from various sources. Secondly, learn the tools that we will use to process the data, for example, Flask and Angular. Thirdly, we explore the data and analyze it, exploratory data analysis, EDA. Fourthly, we clean and prepare the data and separate it into useful data. We train the machine learning systems models using the clean data, develop a dashboard for the web application, and we make an API. At the fourth step, we integrate the back end with the machine learning model. And integrate the front end with the back end, and lastly, we analyze the data from the user interface.
The main sources for our database come from the following databases: Spreadsheet, SA Demographics, Census, Stats SA Publications, Open Africa/Zenodo, and the Department of Higher Education. With regards to data preparation, we've done the following. Spreadsheet formatting of data had to be cleaned and undergo structural changes in order to represent data that had several dimensions. DARISA members helped in this regard and suggested something called one-hot encoding. We specifically filtered for the subset of people who are of appropriate age for enrollment. We also used SciPy's interpolate function to make up for sparse census data, to align enrollment data with population densities over the years. Included in our data preparation was training and evaluating metrics of our machine learning models. Lastly, comparing and finally deploying our models in the backend.
The challenges we faced as a team were stressful and frustrating. Firstly, finding datasets for our idea was very difficult, as finding accurate enrollment information broken down to different ethnic groups for every university is challenging. Secondly, after preparing the tedious and difficult data and initial data evaluations, making the models were extremely challenging as none of us have had any experience with machine learning nor Python. The next big challenge was after we began coding and realized our choice of tech stack was inherently flawed. We had to change our Node.js backend to a Flask backend after struggling for hours on end trying to force Node to communicate with the model. Lastly, integrating everything and testing all the data, UI, and visualizations were challenging as well.
Added value. Trends of enrollments is made available and digestible. Estimated future enrollments is displayed dynamically. Any biases in enrollments by race can be identified. Making comparisons of different universities is easier.
Now we head over to the dashboard. This page is where we exhibit the data that we have processed and presented graphically to find patterns and regularities. Have a look here at the line graph located towards the top left of the screen. It displays the actual enrollments by race of the selected university. A university can be selected from the set of universities listed in the drop-down. Each of the 4 lines represent the 4 ethnicities, races that are being compared: African, colored, white, and Indian. At the bottom left, we have the demographic of South Africa drawn out so we can compare and contrast it with the university enrollment data. The graph on the top right is a more detailed and narrowed down version of the demographic graph. It displays the population of a given province that is between the ages of 15 and 24 years. We chose this age group because it almost entirely represents undergrad enrollments. This graph can be filtered by province. Lastly, at the bottom right, we have the forecasted university enrollments by race. This is the crux of our web application. It uses the machine learning model that my team created using the very same data that was used to generate these graphs you see on screen. The model makes predictions and the output is plotted on the graph. Let's have a look at the enrollments for the University of Cape Town. It would be interesting to note that the coloreds are the least represented ethnic group in the University of Cape Town, despite being the largest ethnic group between the ages of 15 and 24 in the Western Cape. This is a major discrepancy. Furthermore, we can compare the potential likelihood of an African student and a colored student getting enrolled in UCT. The predictions use historical data, so it is unsurprising that a hypothetical colored student has a low percentage at being enrolled at this university.
After a very difficult task of of finding and gathering the datasets from our various data sources, we clean it up manually since we had very little data. We made sure to optimize the data for Pandas as well as for the machine learning models that we made later. In every step of the way, we made sure to analyze and evaluate the data with visualizations. Some of the missing data was filled out with interpolation, such as the census data, and the enrollments for each university according to the race was the data that we used in our machine learning models.
This is the late perceptron model we created. And the multi-late perceptron model takes in two inputs, which is the year and the university that the student is in. And then it outputs four results, which is the ethnicities, gives the total ethnicities that can be in that university, such as African, colored, Indian, and white. Then we use the train test split to split the data that we had, and the test size we kept as 40%, because after doing some testing, we found that 40% was the best and most suitable for this model. We used the multi-late perceptron model, which has 4 layers with 16, 8, and 4 perceptrons respectively, and we used the Adam optimizer for this model. Then we trained the model on the data set. After training the model, we saw the results we found, such as the loss and the value loss, that it was going down, which was a good sign for this model. But the mean absolute error and the root mean squared error was really high, which was a bad sign for this model. And the explained variance score was really low, which meant that we had to make another model to see how it would change. For this, we also plotted the test sets using the model, and we see that the results have many outliers and it's not closer to the line of best fit. Now let's go ahead and have a look at the next model, the linear regression model. Okay. Now this is the linear regression model we created. It uses the same input, which is the year and the university, and it also does the same output. For this, we had a train test split of 20%, which was more reasonable based on our testing that we did. This linear regression model was trained on the 80% of training sets. And after training the model, we saw that the root mean squared error and the mean squared error was smaller than the previous model, which was a good sign, and the explained variance score was really good with 0.99, which is really good for this model. And then we also used the test data and the training data to plot out the graphs to see if this model is working. And we saw that the values were really close to the line of best fit, which was a good sign, and this was the best model that was created. Then the next model was also a linear regression model, but using TensorFlow. This was made for experimental purposes, which uses the same inputs and has the same outputs labeled. For this, the test size was 20% again, but this uses the TensorFlow model with only one neuron, which has 4 outputs. And for this also, we saw the mean squared error and root mean squared error, which ended up being really high, which meant that this model is also bad, and it ended up being worse than the neural model, the multi-late perceptron model, because the explained variance score was way lower than that. And then we used the training set and the test set to plot the graphs to see see how the model is working, and there were many outliers. That means this was the worst model between all of them.
Our recommendations are: number 1, pursue more campaigns for the students that are affected by the discrepancy. Number 2, all students be made aware of the opportunities that they have for studies and funding, especially students that are underrepresented in higher education. We hope that you have enjoyed our presentation. Thank you.
Okay, can you hear me?
Yes.
Okay, thank you. So that was Team UJ who opened the DATATHON presentations for us. So I will open the floor firstly to the judges if they have any questions to the teams, and then after that we can take questions from anyone else.
Okay, hello.
Yes, we can hear you.
Okay, I think I had about 2 questions for the team, particularly on their machine learning models. Firstly, I wanted to know like what influenced their choice of the 2 models, like the linear regression and the multi-layer perceptron one. And I wanted to know if they did find out what caused the multi-squared error to be so high in their multi-layer perceptron model. So those are only 2 questions that I had.
Thank you, Kushata. Team UJ.
Okay, thank you for those questions. Okay, if I remember correctly, you're asking why we decided to choose those 2 models. And I think because we chose the MLP model using the various neurons because our output was multivariate. So it had to produce the numbers for enrollments for the 4 different ethnicities that the census takes, based on 2 inputs in which is the year and the university. So we thought that because the output is multivariate, we thought that the neural net would be better. And with regards to the root mean square error for the, I don't know if you're asking for the linear regression or the neural net model, but I think the answer might be the same for both. And I suppose there's quite a lot of variance because the data that we had was quite sparse. We had university enrollment data from 2009 to 2016, and the census data, because it only happens sporadically, we had to sort of interpolate the data in between those years. So I think had there been more open data on these things, I imagine that the variance would have been lower.
Thank you, Sean. Kushata, does that answer your questions?
Okay, yeah, that's fine. Thank you so much.
Thank you. Noluvu, you can go ahead. Vuvu, I see your hand is up, but your mic is muted. Okay, can we, are there any other questions from the other judges? Okay, if not, any questions from the floor? Okay, Nolu, your hand is still up, so I'm not sure. I'll just lower it on your behalf. Okay, so we will then go on to the next presentation. Timby, so what is the next? I don't have, okay, so the next presentation is going to be Rhodes. So Rhodes, you can go ahead and share your screen.
Thank you, Nobubele. I'm not sure if my sound is clear from that side. Please continue.
Yes, we can hear you.
Okay, great. Oh, sorry, I just need a moment to get access to the slides and then I'll start the presentation.
No problem.
Yes, can you just make it bigger?
Yes, I was just turning on to full screen. That should be okay now? You should be
Yes,
seeing
yes.
full screen. Okay, great.
Okay, your time is starting now.
Okay. Hi, my name is Mantone and I am from Purple Code. We are going to be, or our topic would be addressing the school dropout rate. I'm just going to let my colleagues introduce themselves.
Hi, my name is Caleb, part of the Purple Code.
Hi, my name is Tommy Chunza. Yeah, from the Purple Code as well.
Hi, my name is Lukanyiso and I'm from Team Purple Code. We saw that there would be, in our researches, an increased number of university graduates leads to an increased gross domestic product output in a country. We also saw that if there's more dropouts, that means there's less enrollments, and that means there's less graduates. So we also saw that individual and institutional characteristics are what lead to this. And going deeper into institutional characteristics, we saw that resources are also part of the characteristics. And going deep into that, we saw that the teacher to student ratio is what has a significant impact on dropout rates.
Okay, and so for our problem definition, we noted that there is a problem in the gap between the percentage of learners who enroll at basic education to those who successfully graduate onto institutions of higher learning. So that on average of a 12-year basic education period, if you take a sample of 100 students, only about 40 of them successfully complete matric. And so this problem is a multifaceted problem because higher learner to teacher ratio, although may not be the main factor, is one of the most contributing factor because you end up with teachers becoming overwhelmed and schools not having adequate teachers for certain subjects. Also, another thing that's happening is being reflected at a higher level where you see that a lot of people enrolling are enrolling for specific courses that aren't actually tailored to come give back at basic education level. And so we thought this would be a good way to build our objectives on this.
Okay, cool. So right now we'll be looking at the project objective, right? Where we're going to be looking at the goals that we need to achieve by the end of our research project. So the first goal that we wanted to implement first was to provide better and equal access to education, right? Where we're going to be implementing a learning recovery program, right? Where it's going to be ensuring that every learner who is falling behind, right, they have some kind of assistance, right, so that they are able to catch up to what to the expected learning target. And then the second thing, the second goal was to bridge the gap in the education system, right? We also just trying to ensure that most of the enrolled learners are able to successfully complete their academic journey. As my colleague mentioned that, you know, you can have 100 students, but only 40 of them can make it. You know, I can see that the math is not really that hard. It's less than 50% of people who are actually going through. So that's what actually the goals that we plan to achieve.
All right, thank you, Tommy. So I'm going to be talking more about the study area that we focused on. So the nature of this study is about causal learning, which examines correlations to find patterns and how factors interact with each other in data sets. We have had to critically evaluate the status of education in South Africa. We have had to look at factors such as education under COVID-19. For instance, if you look at the matric pass rate in 2020, it was 76.4%, which is a drop by 5.1% from 2019. Based on this, we have had to ask ourselves several questions. Is the current online system being used effectively? What if we had to use it for 10 more years? Would we still have gaps in the academic system? Is technology access a major cause in the low pass rate? Now, this causal learning model aims to answer these questions from the available data set, and it is conducted to understand the impacts of some of the factors affecting education to make a case for why an intervention is needed to provide better quality education. Thank you. I'm going to pass to my colleague there.
Tommy, are you here?
Yeah, Lucanito is around. Lucanito.
Sorry, I was unmuted. Yeah, this is the methodology that we adapted as a team, and aspects of it will be discussed in detail as we go further along the presentation. Over to Tommy.
Okay, cool. So right now I will be discussing the data resources and data analysis that we use to conduct our research, right? So we can actually see that all the data set that was used in our research was actually put together by the Center for Higher Education, right? And then the data set that we use includes the enrollment by measured field of study, enrollment by qualification type, and the graduate percentages. And all this data set can actually just be accessed by just following the link below here. And then we also made use of this survey paper, which discussed what the COVID-19 and its impact on education and social life and mental health of students. And the same thing, like the data set can still be accessed by just looking at the link below. And I'm going to be passing over to my other colleague.
Okay, thank you, Tommy. So now that we've understood the business of what we're trying to do and we've acquired the data, now it's time to understand what the data is about. So much of the work has been done in the Google Colab file that has been attached for submission, but I just want to briefly discuss them. So we have the first set, which is 3 data sets that contain data from 23 South African institutions over a 12-year period. And that is the enrollments by major fields of study, which have 92 values, which show the percentages of people enrolling in faculties of science, business, humanity, and education. The second one is a percentage representation of undergraduate enrollment at university, that is at undergraduate level, postgraduate going on to masters and doctorates, and at doctorates and master's level. And then the third one is values that show actual graduate percentages for those years. So after some data exploration and analysis, obviously cleaning the data and preparing it in order to be able to view it like this. I just want to make a few points regarding what we noticed about the data, or what the data told us, which is from the first data set, the percentages of enrollment by study from showed that there's about 40% of people enrolling in the science faculty. There's about 31% in business and less than 20% at education. And that is why we chose the theme to try to address the gap that's happening at high level. The second data set shows the percentages of enrollment by qualifications, because obviously at undergraduate level, you have about 90% enrolling. And then at postgraduate and at higher levels, you have a very, very low value of about 3% there of people enrolling. Then in the third data set, or the gist of it, is the actual percentage of graduates from the graduates that came in at the beginning. You see only less than 30% over the 12-year period that the data sets show. And this graph only shows at least the first 3 universities, but the same data is represented in other universities as well. And so just to give an indication of how bad the situation is, I guess, if you look at this graph, it is a representation of what's happened over the 12 years. So the x-axis is in 2000, and then the y-axis is in 2012. So the purple dots show the enrollment of education, and you can see that it is over very small values, even after 12 years. And for other faculties, you see that there are higher percentages reported in that 12 years, and it's been consistent. So based on this, we looked at statistical values of how this is actually a reality in schools, in that although things like this are happening at higher levels, so what's happening, or how is that impacting what's happening at a basic level? So if you look at the bottom row, so after the green row, you will see that from a period from 2017 to 2019, there's about 1 million new enrollments at the basic education level. And then there's only about 10,000 of new educators being enrolled into the schools. And so this motivated our solution to try to come up with an intervention plan for us to target people at higher level to join programs and become educators. So to clarify, the solution does not say people should register for an education degree, but we are asking them to join as educators in the fields that they're studying in order to fill the gaps for areas where there aren't enough or adequate teachers in those specific subjects. And to evaluate the effectiveness of this model, we used 2 algorithms. The first one was a decision tree. And obviously we scaled the data and chose the standard scaler because it had the best accuracy. And based on that, obviously the accuracy of the decision tree, both in the min-max scaler and the standard scaler, is about 46%, which we saw this is not very good. And so we opted for a different one, which would help with better accuracy and better precision. And for that, we went with a logistic regression, and the accuracy obviously improved to about 75% and the precision up to 80%, which is what we wanted. And so this is the model that we choose to implement in our solution, where we build an app. This will be discussed further later, but
5 minutes.
Thank
5
you.
minutes
Okay,
left.
so to support this, the second data set is a description of why we chose this model. So this is a sample of 1,182 students in India. And it shows the time they spend on online class. That is on an average of 2 to 6 hours. The time spent on self-study was about 0 to 5 hours. And then when they rated the online classes, with 0 being very poor and 4 being very excellent, it shows that they didn't really like that class. That's why we chose to implement getting more educators in order to tutor the learners, as well as the fact that the age group is between 10 to 20, which is around basic level of education. And this is the distribution of learners that were used in the study. So
Thank
I
you
will
so
hand
much,
over.
Mantone. I'm gonna quickly go through the possible solution. So after looking at some of the factors to our problem, we decided to dedicate ourselves to this project that will bridge the gap identified. Therefore, the project objectives is create a web application that will allow us to weaken one of the strongest factors in the problem identified, which is, as seen, a shortage in the number of educators, that being teachers or tutors compared to learners. Our web application will be able to register educators around the country whom are able to assist learners with subjects they have difficulties in, register schools whom are organizing programs but have a lag in the number of educators, register learners who are individually struggling, also show available educators and tutors in the system. This app will allow the learners and educators to communicate painlessly and at any time. We have included in this presentation a couple of the wireframes before we actually created the actual app, but we attached it inside this link of our submission. As you can see easily there, you have a choice to add an educator, add a school, or add a learner. And clicking through each and every one of them, you can go through, add an educator. You will get the point, the forms, and the necessary information to add an educator, the subjects they're willing to teach, and the availability which they can offer. If you go to the school as a school, registering as a school on this app, you get the necessary details of school, which subjects you are lacking in, which grades are you actually also lacking in, and the urgency of that position. You can also register as a learner. Going through that, you have the necessary details of the learner, which grade you're doing, which subject you're struggling with, and submitting. Please note that this is a wireframe, and the app actually does way more better and it is more complete. Thank you. I'm going to pass to my colleague.
The solution is intended to help learners successfully complete their basic education by equipping university students to become educators in their respective fields, in a way recycling the information that helped them be there, and also instilling a mentorship and volunteering culture. In line with that culture, we recommend encouraging educators specifically for training of online technical skills at a basic education level. We thank you so much for our presentation. This has been Team Purple Code.
Thank you, Team Rhodes, Team Purple Code. I will open the floor to the judges to pose any questions. Okay, I don't see any hands. Are there questions from the floor? Kushata, are you asking a question?
Let me just say it's more of a comment. I would like to comment the team on how they defined their background and the problem statement. I think that came out very, very well. As to the solution, I think I only had a little question like, is it just a website where you have like educators and students registering, or is there more to that, or is just like a registration website? I wasn't sure if that really came out for me. I don't know if it's clear enough. I think those were the only two things that I wanted to mention.
Okay, thank you for that question. But from the perspective of the user, they need to register, and then what the system will do is then it will try to allocate learners to any available tutors. And what we're trying to do inside that app is to try to assess the effectiveness, I guess, which is why we chose the second model. We're trying to assess the effectiveness of, is this method that we're trying to implement here working? And so it's not just looking at applying, you're looking at, well, after you apply, what happens? Does the progress of the learner increase? You know, like overall or over time, does that provide for better education?
Okay, thank you.
Answered? Okay, thank you. Some comments. Sean says he really likes the implementation. Well done. Stones is impressed, and Nolu says your solution was very practical and and they loved how you used your data set. So thank you, Team Rhodes. So up next, we have University of KwaZulu-Natal. So you guys can share your screen and get started.
Greetings to everyone.
And make it full screen. Okay, thank you. Your time starts now.
Greetings, everyone. My name is Noanda Mteto from Team UKZN, the Explorers. My fellow group members are Puma Palala, Mangaliso Mgomezulu, and Mkhulu Limanini. We are presenting under the topic says increase the number of people with relevant skills for financial success. Here is the content. I will talk about the first part, background problem statement, and project objective. Background problem. The study have shown that public higher education institutions mostly produce undergraduate certificates, diploma or degree holders. In 2016, 72.4% of graduates had such qualifications, with 46.2% graduates with degrees, 28% in business and management, and with 21% in education, lastly 7% in engineering. However, the share of graduates in key STEM fields amounted to only 29% of all graduates. The study also shows that among the youth aged 18 to 24 who were not attending educational institutions, 48% indicated that they were prevented from participating by their poor performance. Problem statement. Here's our theme: increase the number of people with relevant skills for financial success. The problem about the skills we need for employment and education is shaped by labor market trends and patterns. STEM skills are usually in great demand. Project objections. Explore the job markets and common prerequisites qualification for high demand jobs. Explore the qualification for graduates produced by tertiary institutions and their prerequisites high school subjects together with their job markets relevance. Study the determinants of financial success in the context of South Africa. Obtain data sources by exploring some possible success indicators like standard of living, quality of school infrastructure, knowledge of the job markets in relation to their possible, if any, on success through education. Investigate and analyze open data on explored topics, so to conclude on the relevant skills and how they can be obtained by many to increase the number of people with relevant skills for financial success. Thank you. I'll let the other group member to elaborate in the next slide.
Okay, thanks for the opportunity. Our part is like to look for the study area, methodology, and data resources we use in our projects. My name is Puma Palala, and I'm from UKZN Team Explorers. Okay, first of all, these projects rely on an open data from South Africa only. These projects only look at how the chances financially success can be increased through education. There might be many ways to increase the financial success, but the scope is limited to education. With many age groups in the country, the project is primarily focused on making youth to be more skilled with relevant skills for financial success. With consideration of the project, these projects at some point rely on very narrow data sets, some of which will then expand more and more data sets will also be needed to pick up whatever conclusion can be drawn there. The GDP per province data set is in more summary for the detail. only well-known curriculum is involved in the study, with more focus on subjects and less focus on extracurricular activities. We then go and look at the methodology. First of all, what we do is like we first find the first data sets of the interest where it is described in terms of the characteristics or the type of data they should contain. We then use data sets where then collected reliable sources, then cleaned in readiness for exploration. We then do an exploration. The exploration was done on the data set. Some questions were addressed and some tricked during the exploration. The data was then analyzed to find out about the relationship between the information that could be extracted from the ones we have. To further enhance the analysis, most of the key data was visualized and carefully observed. We do so by using the software. The software that was used to visualize the data is Jupyter Notebook. And then some conclusions were made, some critics like limitation of the data were noted from the data. Any possible bias from the data was noted. Final conclusions were drawn and recommendations were made on how the solution to the problem should be like. We then have data sources. And then we then have data sources. Under the data sources, we have data set type of source link, and we have a link. So at the data sets we use is job market, provincial GDP, graduate statistics, high school subject choices, provincial performance. I will hand over to my group member, Mangaliso Mngomezulu, who is going to explain more about data analysis.
So on our data analysis, the first graph that we're going to be looking at is the ratio of graduates and versus the ratio of the high demand jobs. So in getting these ratios, what we did, we looked at the graduates who are coming out of universities per year, and we grouped them by the categories, which are the science categories and the humanities, and also business and management and the other fields. So we did the same for the jobs that are in high demand from the data set that we had initially. And then for each of the categories, we found the ratio of each. And then in this graph, we see the relationship between the ratios. So what we can conclude from here is that about 29% of the graduates qualify for about 96% of the jobs that are in demand in the job market. Going to our next graph, so what you can see here is the careers that are in demand in the job market and the potential qualifiers. So our potential qualifiers, we just focused on the high school students. So what we realized about the data set from high school students, we saw that about when the job market demand increases for some specific jobs, there's very few students at the high school level who are already able to qualify for those jobs in the future. So we looked at the choices of the students in their metric, like judging from their metric exams. We looked at the proportionality of the distribution of the students among the subjects that are decisive in terms of their classification of the qualifications that it can qualify for at the tertiary level, by also looking at the prerequisite subjects from high school for the tertiary level qualifications. So we also explored the data further, and we looked and tried to visualize the data from every perspective that we could. So the next thing we looked at here is that from the STEM field, or which is also known as the science, technology, engineering, and mathematics field. So what we realized from that is that the students who can qualify are about 33% of the students who are still in high school. And for the commerce field, we realized that it's about 77%. That includes all the STEM, the students who can also qualify for the STEM fields. And we realized that all of the students who are in high school have got the potential to qualify for all the careers in humanities and education. So what follows next, here we have this graph that looks at the pass rates per province. So the provinces are on the x-axis and they've been abbreviated. So as you can see here, the pass rate is different per province, but what you can judge just by looking at the graph. Roughly, the pass rate is about 75%. If you join maybe the leftmost end with the rightmost end, the line will be just increasing slightly, and its gradient may be it should be reasonable to say that the average pass rate is about 75%. So we're exploring the pass rate per province. Sorry?
Yeah, 5 minutes.
Okay, so we're exploring the pass rate per province to get to some conclusion in the next slides. So in the previous slide, we looked at the pass rate per province, and in this slide, we are looking at the GDP contributed by each province in our economy of the country. So we want to compare, we want to see if there's a relationship between the GDP contributed by a province and the pass rate for each province. So as you can see in this distribution, Gauteng province is the one with the highest GDP contribution. So comparing that data now for looking at for each province, we're looking at the corresponding pass rate and the provincial GDP contribution, we realize that there is indeed a relationship. As the provincial GDP contribution increases, also the pass rate increases. So also we looked at some of the things that could be problems for students. So we're still like doing most of what is the exploration of the data and visualizing that. So we looked at the distribution of bachelor's degrees per income quintiles from students. So as you can, what you see in the pie chart is the distribution of the proportionalities of bachelor's degrees, like from different quintiles. So these are different income quintiles. So as you can see, the bigger section is for the highest income quintile, which means that there is a possibility that the income of certain quintiles also has an effect on the probability of the success of the students. So what we have in this graph is the pass rate per quintile. So some of the data, like the total amount of students taking the examinations per quintile, was simulated in this case with the constraints of looking at the average of number of students who take the exams per year, and also looking at a data set that was existing, which was the number of schools that are available for each quintile, and then we use those ratios to simulate the data. But what we can see is that as the income quintile increases, or we can just say as it increases, like from the x-axis, although it looks qualitative, but really it represents an increase in income. So as the income increases per quintile, the pass rate also increases. So we're able to deduce from here that the income is related to the pass rate. So I'll pass to my colleague, Mkulu.
Greetings, my name is Mkululi Manena and I will be presenting the solution. The government must ensure that all schools meet minimum standards for infrastructure and commit to progressively upgrading its school infrastructure to meet optimum standards. The government must also explore the use of mobile devices such as phones and tablets in distributing learning content. The recommendations and future work, the curriculum must be adjusted to allow most pupils very early to learn skills that will make them competent for fourth industrial revolution jobs or skills. Skills planners must be available to understand these shifts in demand if they are successfully assisting in building and maintaining a capable workforce that corresponds to the need of the economy. Given more time, part of the solution will be a mobile application that will allow people to enter combinations of subject choices and view jobs that are in high demand or jobs that are expected to be in high demand in the future, relevant to the choice of subjects. That is all from our group. Thank you.
Thank you, team UKZN. So I will just open the floor to the judges to pose any questions.
Hello.
Yes, we can hear you.
I wanted the team to go back to the solution. I don't think that came out really well for me. The team, what is the solution? What did we come up with? Can we hear that once more?
Mangaliso, can you share the slides again?
Yeah, I'm just sharing now.
So the solution was that the government must ensure that all schools meet minimum standards for infrastructure and commit to progressively upgrading each school infrastructure to meet optimum standard. This is because from the graphs that we were shown above, it is seen that quintiles that have higher income seem to be passing very well in school. So that's how we came to this conclusion. And the government must explore the use of mobile devices such as phones and tablets in distributing learning content. This is for the technology part, which is STEM. And yeah, it is low.
Okay, yeah, that's fine.
Okay, thanks, UKZN. Are there any questions from the floor? Okay, I think just from my side, it would have been nice. I think it also links to Kushata maybe not understanding the solution. I think we see your data analysis, but it would have been maybe ideal to take it forward and produce a solution based on now the analysis work that you guys had done. But thank you for your presentation. So up next, we have the University of Mpumalanga. So you can proceed to share your screen. Mpumalanga.
I don't know if my screen is visible.
Yes, you can make it full screen.
Is it okay?
Not yet. Yes, it is. You can proceed. Your time starts now.
Okay, I'll hand over to Kinos on the other side.
Good morning, everybody. My name is Kinosi Poe, and I will be representing the University of Mpumalanga. So our subtopic for today will be equal access to technical, vocational, and higher education. Now, our background to the problem is that it is a known fact that the country cannot develop without equal education and training, as well as vocational education. Sorry, I'm so sorry. Yes, so now problems differ from low attendance of students and the lack of facilities and materials for training for the students. Now, there is also inadequate as well as limited facilities, limited number of training institutions for technical teachers and facility in career programs to navigate public institutes and public attitudes and perception and technical and vocational education training. Well, our problem statement is that the quality and accessibility of education is a key factor for our country's competitiveness with the sociological transformation of society. Now, with the COVID-19 being an impact in our lives, we are forced to digitize certain requirements to the education system. Now, students from secondary to universities are also the readiness of teachers need to adapt to the new education process in order to implement digital technologies into education progress. Although equal access to education is narrowing as opposed to technical and vocational skills, more women still need to face technical and vocational skills. And this means that practical skills as opposed to men, as there are still jobs that put preference to men specifically.
Okay, thank you.
Now, our objectives is to ensure, sorry.
Okay, sorry about that. Thank you about that, Kunesi. And right now we're going to the objectives. What we thought about is to, one of our objectives or goals is to ensure equal access for all and also be affordable, and also the quality of it to technical, vocational, and also tertiary education. And also to limit the gender inequality, as most learning and technical and vocational institutions are male dominated. Also to eliminate gender discrimination in education and to ensure equal access to all levels of technical, vocational, and higher education. On our methodology, it's to find and retrieve different sources, clean data sets, and also separate them into usable data, and also visualize the data. And from our data sources, the data set that we downloaded was the enrollment by gender, which is because it provides us with a number of students enrolled in each, and which can be categorized by the gender educational institutions. The other one was student enrollment, which provided us with the number of enrolled students at the institution and then the number of graduates. The other one was sources of income, also the type of funding, which determines the number of students who were able to fund themselves, and also those who were funded by the government. And I'll give over the data analysis and results to my fellow student, Mohamed.
Good morning once more. On the data analysis and results, we've used Pandas to view and clean our data. And we've also used Matplotlib was used to form part of the visualizations. If you can move on to the next slide, Joseph, so that we can show the visualizations. If you can see on the next slide, there's a line graph. There's a line graph of the number of females compared to the number of males enrolled in some of the universities. We've mainly listed 4 of them. And on the far right again, you can see the number of enrolled and the number of graduates. Let me start with the line graph. As opposed to males, you can see that in CPUT, there were a lot of females which were enrolled compared to males. But then if we move along to other universities, you can see that the number of females was starting to decrease a little. And on the bar graph, the number of enrolled students compared to the number of graduated. Normally, universities can enroll a number of students, and on that number of students, you can find that only a few of them will be able to graduate. And as you can see in CPUT in 2015, about 30,000 students were enrolled, and only about 7,000 or 6,000 students managed to graduate. So goes for CPUT again in 2017, about 34,000 students were enrolled, and only about 8,000 of them managed to graduate. Can you move over to the next slide again? Here it's also a line graph of enrolled and also a line graph of the number of the graduated students. As you can see, a lot of students are enrolled, and the number of graduated students, it's way more or less compared to the number of enrolled initially. And you can see on the pie chart there, on UCT, only 20.1% managed to graduate. On UCT, actually, 20.1% managed to graduate. CPUT only 19.0% managed to graduate. Free State 7.9 managed to graduate, and University of Fort Hare only 5.8 managed to graduate. DUT 32.7, and CUT only 14.5 students managed to graduate out of all the enrolled students. Can you slide again? Here we have a bar graph of self-funded versus the government funded, and also private funded, mainly scholarships. If we can check on the government funded, in 2010, about 0.4% of them were funded, and the number of self-funded students was 0.3, and privately funded was about 0.4. The reason why self-funded students it's way too low is because some students can fund themselves, and along the process they find it hard to keep paying for themselves. And as for the government funding, yes, they can fund you, but then there are certain requirements for government funding. That's why the number of government funded students from 2010, 2011 to up until 2018, it's decreasing based on some of the requirements that you need to have actually. And the reason why private funded students or private funded percentage of students, it's way more lower, or it's not even high. It's because their requirements are way too high, and only a few students are privileged enough to have that sort of funding. And also on the pie chart, it's also the same thing. You can see in 2012, it was 10.5% of private funded students who were funded. And if we can check on 2011, it was only 10.9% of self-funded students who managed to fund themselves, 10.9%. Then in 2010, only 10.1% of government students managed to. Thank you. Okay, Joseph, can you please move over? As a proposed solution, we've planned to make a reach out programs to students to emphasize the importance of education. Mainly, you may ask yourself, how do we plan on doing that? Although we haven't created a solution like a practical solution, but then theoretically, we're planning on creating skills development centers, or maybe a website whereby more women can be pursued to have certain careers. As you've seen that now, the world it's a male dominated world as of now. A lot of fewer females have fewer opportunities, and also again with on the website, maybe we can also include some of the bursaries or funding for self-funded students, so that they don't have to take the strain alone. And also we plan we can also include maybe a few things like for the bursaries, in terms of the requirements. Maybe they can minimize the requirements so that all learners can be able to also enroll in higher institutes. You can move over, Joseph. And in the conclusion, technical and vocational and higher education plays an important role in the overall development of the nation. It also plays a crucial role in this sustainable development. The first role is to provide training opportunities and career advancements for the students who don't want to continue the general education, and it will help children dropping out, and it will also provide the skilled human resources needed at all levels of the national economy. Tati, can take over.
With the conclusion of challenges, we had challenges with cleaning the data, finding relevant data, especially the ones we used for our sub-theme, because while we were busy trying to find data, we struggled a lot finding data that was specifically for the sub-theme that we had chosen. Using Pandas, because it was our first time using such, and then extracting data for different data sets was also a problem for us. learning Python was not a big challenge, but it was a challenge. Thank you.
Thank you, Team Pumalanga. Nolovuyo, do you have a question? I see your hand is up. Hello.
Yes, ma'am.
Okay, no, there's a hand up, but I don't think there is an actual question. Oh, sorry, Kushata, you can go ahead.
I didn't hear any recommendations or any future plans from the team.
You didn't hear any recommendations for, is it future work, I assume? The team, oh, okay, will you re-ask your question, Kushat? Or type it? Nolovuyo, your hand is up again. Do you have a question? Okay.
It's just a comment. Sorry, my signal is really bad today.
Okay.
What I've picked up from all the groups in terms of the problem statement, it's a datathon, and I'm surprised that a lot of the problem statements that are coming across today don't bring much data or stats across to validate what you call this, the problem. I think it's something to note for the future. And also, it's very beautiful solutions that are being presented this morning, but some of them could potentially be narrowed down and be direct and be more focused. At times they are too broad, but it's a beautiful morning in general.
Thank you for the feedback, Nolu. So, okay, Kushata's question is around the team's recommendations and future plans. So could you maybe go back and elaborate on that?
Okay, in terms of our future plans, was to maybe like have a richer program, which is one of the solutions that we like to implement. Have a richer program whereby awareness will be made in terms of like giving women a chance in terms of the technical and skills and also the vocational skills, whereby they could acquire those skills, and also maybe a website whereby it's like a job, what can I say? A job skill centers, so sort of whereby women also like maybe the youth in particular can go onto the website and just find the jobs that are related to their technical skills.
Okay, the next question is, what issues did you have with cleaning the data, and did you use Pandas or something else to clean the data?
We used Pandas to clean the data. Some of the issues we encountered was that when loading some of the data sets, you'd find that the tables are how can I put it? They are messed up. You find that the column names are inside the rows, and some of the rows are at the column names. So we struggled to sort those type of problems. That's mainly the issues that we encountered.
Okay. I think in one of your visual graphs that you showed, there was a year that was written 2044. So I was also a bit confused by that, if maybe that row or that specific data was it included by mistake or?
I think it was included by mistake. That's one of the issues we encountered, such that some of the column names, you find them inside the rows. So we didn't pay attention to that detail. It was a typo.
Okay, all right, thank you. I don't know if there's any other questions. If not, we will move on to our last team before the break, which will be Val University of Technology. So you can share your screen and proceed.
Guys, can you see my screen?
Yes, we can hear this. Good afternoon, everybody. I'm Sofazo from Val University of Technology, and my teammates, it's Jennifer, Khoto, and Farrell. So we'll be focusing on the university dropout issue that we have realized, which is constantly rising each year. I'm Sofa and Farrell. Sorry?
Farrell, can you like switch off your mic?
You can continue.
Should we start from scratch or?
You continue because your time is going.
Yes, so our main focus will be on the university dropout issue. In our presentation, we are going to focus on the background of this problem and then do a project statement, do an objective and study area, the methodology, data source, data analysis and results, and the proposed solution and conclusion. With our problem background, we realized that there is a constant increase in the dropout rate in South Africa. And this is normally first years who would literally drop out. We have realized from our research that 50 to 60% of the students would drop out. This results, we saw it from the Fundi website, which showed us the results of this issue. So the increased rate of dropouts is normally caused by the financial issues that students would go through each year. You'd find that a student only saved, or they only did calculations for the tuition fees, forgetting that there is a certain amount that they also need to pay, these additional amounts as well. You'd find some students would get job opportunities and then they end up dropping out because they are unable to balance their studies as well as the job opportunity that they have received. Some students would have family commitments and issues. Females will become pregnant. At the end of the day, they are unable to complete their studies and they need to focus on the child. And we also realize that quality education is another factor, another cause for students who would drop out. With the quality education, we realize that universities would teach students skills which are sometimes not relevant or they are not in demand. And that specific students would want to be taught something that they will use in the workplace. So all this, we've realized that the more there is an increase in the dropout rate, it causes another increase in the unemployment rate. And it also affects the criminal behavior. There is an increase in the criminal rate as well. With our problem statement, we realized that due to the increase of the high rate of dropouts, we will need to focus on this and find out what could be the causes. For our project objective, we're going to identify the rate of university dropouts in South Africa. So our main focus was in universities in South Africa. For our study area, we have identified certain points, and at the end, it will help us with the results. So we are going to evaluate the high rate of university dropouts, and we are going to focus also on the rate of enrollments in universities, because you'd realize that many students would enroll at the beginning of the year, and then at the end, students would start dropping out. And we realized that this causes a decrease in the number of students who would graduate at the end.
Good morning, guys. For our methodology, we identified the study area of the problem. We then developed a hypothesis. The hypothesis that we developed, we have identified is that many students enroll at a specific university and only a few students graduate at the end. This shows that the rate of student dropping out is high, and as a result, only a few students graduate. We then collected data sources that assisted us in predicting the rate of university dropouts. At last, we trained our matching model to predict the rate of university dropouts. With our data sources, we got them from Stridom, which was written by F. Bassin and Metz M. From a survey of student engagement, enhancing the quality of teaching and learning, using engagement data to establish a culture of evidence. And then we got our data source from CHT, which is Center for Higher Education Transformation, under the topic clustering of South African universities into distinct groups based on input and output indicators. Thank you.
Thank you, guys. I'll be taking over in terms of data analysis. So these are the steps we went for when we were doing our data analysis and trying to predict the number of dropouts. First thing first, we cleaned our data set, analyzed the number of applications accepted versus the institution response. The data we used contained less redundant data. We also dropped out columns which didn't serve any purpose. So these are the screenshots of these are the screenshots whereby now we were refining data and stuff. So we used IBM Watson Studio to do all of this. So we started first by creating a project and went by deleting some of the things, some of the columns which we didn't need, and then afterwards we created the job which would later serve as a deployment of our model. Then we went straight by and we went to choose a machine learning model for our data to test our data sets and train them. When we were doing the testing and the training of data sets, we went through a process whereby we let our machine model do the testing and the training of the data set. We patiently waited till the machine model did the process of pre-processing data, trying to train and test the data set. It went through all the steps, the pipelines, to show how our data is relevant to what we were predicting. So most of the pipelines we found were mostly focusing on linear regression. So at the end, we saved one of our linear regression pipeline, which was pipeline number 3, so that we can use it to predict and deploy our model at the end. So at the end, for us to predict the number of dropouts, we went to deploy the model and inserted any value of our choice so that we can check the accuracy part, which gave us around 75.86. Then we went to visualization of data. This is a multi-series chart. This shows the number of applications vis-a-vis the acceptance of applications. We can see that there were a number of applications received by a certain university. Then it's slightly increased as time went by. Then only a few were able to enroll due to unforeseen circumstances like financial issues, job opportunities, and family commitments.
5 minutes.
Okay. This is graduation. This chart is a pie chart whereby now is a graduation rate vis-a-vis the future undergraduate. It seems to show the unbalanced data in terms of the graduation rate at the end. I'll give over to Father.
I will be presenting the proposed solution. So we suggest that university may improve curriculum development and teaching practice, ensuring greater equity and supporting students, and improving resource mobilization. So classroom must be equipped with computer lectures generation, robotic lab, and network lab, so that students can be able to learn new technologies such as IoT, 5G, and all its implementation. The next step is, in the absence of fundamental change in the schooling system, university must adapt the curriculum and teaching method to cater the majority of students in the system. So we mean that we don't have the same capacity to analyze and to learn and to give back what we learn. Some are fast learners and others are slow learners. So university must come up with a new approach of teaching, a new way of evaluating students to make them feel comfortable regarding specific subject. There are some subjects which are looking intimidating and students get frustrated when they don't understand the topic. But he, the lecturer over university, make them feel comfortable and make the subject look easier. It can affect the student performance. Academic development requires institutions to adapt their offering to accommodate a greater diversity of educational preparedness. What do we mean? We mean that, let me explain. For example, we must include new technology in their offering: computer science, deep learning, IoT, AI, data analytics, data business analysis, and many more. So they can't keep using the same offering from 10 years ago. The world is changing, so we must prepare, we must adapt, so that the next generation must be able to solve their problem that we will encounter. Otherwise, we will be held responsible for the failure. Okay, let me just take an example. We all know Apple. But did you know that most of the engineers and programmers are from MIT? So let me ask you, what is the probability of a student from UT or Limpopo to be accepted to Apple?
2 minutes.
And the final step is encourage private sector and participation through the adoption of simple accreditation rules similar to that for public institutions. So in conclusion, an increase of dropout rates cause an increase of unemployment rate and criminal behavior. Thank you. Any question?
Thank you, Pharrell. I will open to the floor. Are there any questions from the judges first? See, okay, there's also no questions from the stream. Okay, if there's no questions from the judges, are there any questions from the audience, from the people in the room? Okay, there's a question on the chat about dropouts. Does that mean students leaving university or changing a degree? So what is the dropouts?
Sorry, come again? You didn't hear
The
properly.
dropouts. So you were investigating dropouts. So the question is asking, by dropouts, do you mean students that are leaving university or changing degrees?
Students that are leaving university.
Okay. So question one, it is students that are leaving university. Then question two, linear regression is sometimes referred to as just statistical modeling. Did you try other machine learning models?
No, we didn't try other models.
Okay, and what influenced your choice for your chosen model? Why did you choose the model that you decided to use?
We felt like the model we chose was more easier than us having to code the whole thing and having to like remove some of the things using the code and stuff. So the model also like it was easier to give us like what's the results at the end of the predictions we were looking for.
Oh, okay. So it was about ease, maybe not best fit.
We couldn't find we couldn't find like what's the best fit, the best that was the best model we could use for our what's this for our program statement. So we went with what we came across, because now we were trying to we were trying to like save time because we were racing against time when we did the whole thing, the whole model thing.
Okay. No, understood. Okay. Are there any questions from the audience? If not, we will take a short body break because I think we're still within time. So we'll take a short body break for the next 7 minutes and we'll start again at 11:20 sharp. So 11:20 TUT needs to start their presentation. So we can just take a short break for now and we will be back like at 11:19 and yeah, TUT can start at 11:20. All right, thank you. Okay, we are back. TUT, you can share your screen, then we will start at exactly 11:20.
Is my mic audible?
Yes, your mic is audible and your presentation is, so you can go ahead.
Oh, good morning, everyone. My name is Tato Kujoane. I'm a member of the Pattern Pros, and we are going to talk about the model we have built for the DATATHON 2021 challenge. So the theme of this year's DATATHON challenge was based on quality education. In building our model, we have seen that truly in South Africa there is a crisis of quality education. We have seen that over the years, some provinces in South Africa have been continuously performing below the national standard. This may be due to some spending irregularities in some of the districts. So our project objectives as Pattern Pros, we intend to identify certain attributes that affect the pass rate of the South African district named Fezile Dabi, located in the Free State. We also intend to use machine learning to predict the pass rate given certain attributes measured. We also intend to develop a system that will be used by the education sector to get the predicted pass rate of Fezile Dabi when a few attributes are modified, that is either increased or decreased. So I will allow my colleague Leslie Sipogu to continue with the presentation starting from the study area.
Hello, I hope I'm audible. Okay, so the study area of our project is the metric pass rate. So the question that I want to answer about the metric pass rate is the metric rate satisfactory? Are there any regions that constantly perform poorly? What factors affect the metric pass rate? And how strong is the impact of these factors on pass rate? So the methodology, the first one is going to select one of the best performing district. We're going to identify the district schooling environment, like learners per grade, facilities, number of independent schools, number of public schools, number of farm schools, and number of quartile schools, which range from quartile 1 to quartile 5. Then the third methodology is we're going to perform pass rate prediction depending on learning environment by supervised learning using perceptron model in Python. Our data sources are as follows. Our first data source was from Fezile Dabi, learners numbers per grade. Then our second one was from Free State pass rate. Then the data above has been simulated. The identified district was Fezile Dabi, right? And the Fezile Dabi Resource Center has 1 hall, 2 computer labs, 1 biology lab, and 1 science lab. So now I'm going to hand over the next slide to my colleague, Matebula.
Hello, everyone. I'm Divani Matebula. So our overview of the correlation of the identified parameters is like this. The data values close to 0 do not correlate and are not useful, but the ones that are close to 1 correlate more and making them useful. We did plot the identified parameters as they relate to each other. Our scatter plot of the pass rate versus data year, we noticed that there is a trend that the pass rate has been increasing over the years. And this is our scatter plot of the number of students in grades versus data year. The trend here is that the number of grade 12 students have been increasing year over year. And here is our scatter plot of the number of quintile schools versus data year. Here there's an inverse trend where the number of quintile schools has been decreasing over the years. So I'll be handing over to Maluleka.
Thank you, Divani. So for a model we chose the perceptron
Or Malulega is breaking. I don't know if it's me.
We saw
maybe someone else can take over from him.
Okay, can you please mute him?
Accuracy was very low.
Okay, so our data analysis and results are as follows. From the model and machine learning done, we obtain an accurate score of 7.1%. This is a low figure that gives us little confidence in the model. It should be noted that 3/4 of our data used was stimulated. That's why we have a low score. Okay, this may explain why the model score is very low, making this mere a proof of concept. Conclusion and recommendation in future work. From the data modeling and machine learning done, we obtain a low prediction score of 7.1%. Stimulated data formed 3/4 of the data used due to the fact that we had a little amount of actual data for machine learning to occur. We had 10 years sample with one sample per year. Because some of the data was stimulated, our model was not that accurate. The education department should unveil more data. The solution, however, can be used as a prototype, but more data is available. Thank you.
Thank you, team. Okay. Are there any questions from the judges? Okay, any questions from the audience?
Sorry, no, Bella, just a question from me. Sorry about that.
No
I was actually
problem.
on mute. Very well done to the team. I just wanted to find out, as per your recommendations, can you recommend how your model can be actionable? I see that it's got the possibility of creating great insights, but I was wondering if you come up with... Hello?
No, you can go ahead and say.
Oh, okay. Yes, but I just wanted to see if you guys could give recommendations as to how your models can become actionable. So how do we actually action those insights that the model is capable of producing?
Guys, did you hear the questions? So how can you make your models actionable? So I think it's basically relating as well to like what we've been saying to some of the teams, that we not seeing the solution part when it comes to the presentation. So maybe team TUT, you can answer and just tell us how this would be implemented or actioned.
Okay, I'm not sure if I understand the question correctly, but then what I can say is what our application does, it takes a few attributes. Okay, like if you can see on this table here, right? It's showing what that on the number of students in grade 12. Yeah, we can hear you.
Can I kind of ask, maybe someone can just let me know the question? Sorry for the disconnection. Infrastructure is not the same everywhere, you know.
Okay, Kosali, do you want to re-ask?
Yeah, maybe let me re-ask while we have the slide up here. So just a basic example, right? Here you have an insight that says the trend here is that the number of grade 12 students has been increasing year over year. So taking that bit of information, what actions can I take as a solution to help solve the problem? So that insight that you put that up there, can that be distilled into an application of some kind, or a procedure or a system that can actually work on this and action this insight into an actual solution?
If I may take this question, colleagues, I hope my sound is still good. So the intent for this project for us was to develop an application where you could input certain factors. So the factors of focus for us were things like number of grade 12 students in a class or in a grade, the presence of computer labs, science labs in a school, the teacher-learner ratio, for example. So if we can do machine learning on these figures over many years, for example, then we might be able to make a prediction on the pass rate to say, okay, if tomorrow you change the teacher-learner ratio, the pass rate should increase by this much. So that was the intent. And we're going to develop a web application where you can change these variables, let's say, and it will let you know what the pass rate would be. So this will be useful for, let's say, the government, for example, where they would know what impact would me giving the school more money have on their pass rate, or what impact would us going on a concerted effort to have more teachers in that school, what impact would that have on the pass rate? I hope my sound was good.
Yes, no, your sound was good. Okay, thank you so much.
Thank you, Kuseli. Are there any other questions from the floor? Virtual floor. Okay, if not, we will move on to Sol Plaatje University. So SPU, you can share your screen.
Can ma'am please confirm that our screen is visible?
It is visible. You can just make it large.
Yeah. Okay, thank you, ma'am.
Time starts now.
Greetings, we are Team Shreddon from Sol Plaatje University, and we are aiming to look at the key indicators to improve and monitor the learner retention strategy. Education is a fundamental human right and a central factor for the 2030 Agenda, the Sustainable Development. The SDG ensures quality education and promotes lifelong learning. The target is to guarantee quality education for every child by 2030. However, the high school drop rate has received significant attention during the past few years. 500,000 more learners have dropped out during the pandemic. This may have tripled from 230,000 learners pre-pandemic to 750,000. As a result, this interferes with the Sustainable Development Goal to ensure quality education and to promote lifelong learning. Based on the given definition of quality education and the background, the school dropout rate hinders the Department of Basic Education from producing learners with good quality education, thus having an indirect impact on the GDP, unemployment, and the crime. Barely 50% of the youth have completed their matric, and the highest unemployment was realized on those who do not have matric. To cap the dropout rate, the Department of Basic Education implemented the learner retention strategy, which introduced several initiatives to improve education access and retention, but the dropout is still on the rise. This clearly states that a gap still exists in identifying learners who are at risk of dropping. Therefore, our project aims to use data analytics to describe and identify possible dropout indicators to improve the learner retention strategy. The objectives of our project is to understand the trends in the learner dropout through data exploration and visualization, using structured and unstructured data to understand possible explanation for learner dropouts, using machine learning to predict the likelihood of learner dropouts. Our scope specifically focuses on learner dropout with the aim of improving quality education. And as stated on our aim, the project seeks to identify key dropout indicators which will be used to improve and monitor the learner retention strategy. This will in turn enable the Department of Basic Education to have a better learner intervention strategy and also sustain the lifelong learning opportunities. The proposed solution is to conduct a sentiment analysis on how the public views the dropouts, analyze grade 1 to 6 learner involvement and determine the dropout rate, forecasting grade 1 to 6 learner involvement over 5 years, using the CNN model to predict the likelihood of learner dropout and to identify the possible dropout indicators. Our data that was needed in order to achieve our objective was the Twitter data, the UN data, and the activities of young people data set.
Thank you. So we'll start with the Twitter data set. Regarding the data collection, we scraped Twitter from data using the Twitter API developer's account, and we scraped keywords, for instance, college dropout, hashtag dropout, like high school dropout. And we also scraped data from this one user called @0dropout, which is a national campaign that focuses on halving the rate of school dropouts by 2030. So regarding the pre-processing, we dropped columns, for instance, the ID of the user and also like the location of the user because that information is personal and it is not necessary for our analysis. So further on, we clean the data. We clean the text by removing, for instance, stop words, punctuations, emojis, and etc. We also drop tweets that were repeating themselves so that we don't repeat data in our data set unnecessary. So we also did visualization and analysis. For the UN data set, we did pre-processing by doing feature selection, as well as visualization, analysis, and forecasting.
And concerning our activities of this dataset, our dataset was developed with the objective to understand the extent of children's involvement in the economic activities. With the pre-processing in Python, we removed all columns that had over 50% missing values, and our columns reduced from 137 to 87. And we did missing value treatment where from our data frame, we split the data into different data types, integer, float, and object. With the object data type, we used the mode to replace the missing values. The integer data type didn't have any missing values. And with the float data type, we replaced it by the median because the columns had students. And in R, we used the Baruta algorithm to encode our 84 variables for our CNN model. And after encoding, we ended up with 36 variables. In the CNN, the reason why we chose the CNN model is because we have a larger data set, even though we could have used the logistic regression or naive base.
Thank you, Anna. So our data analysis and results. So we are going to look at the Twitter data set as well as the UN data set. We're going to demo it on dashboard. So here underneath is a link to our dashboard. You can click on it and you can go through it with us. As well as our UN data set has its own dashboard. So it has its own unique URL. So I'll quickly go and demo the dashboard. So this is now regarding the Twitter dashboard. So we have, for instance, you can view the data set, you can see the shape of the data set. You can view the columns in the data set and also clean the tweets. And as we said, drop the tweets that are repeating. So what's important is we did the polarity and the subjectivity. So we wanted to find out how positive, negative, or neutral a tweet is and what the emotions were in it. Was it very emotional or not so emotional, like how opinionated it was? Regarding the data visualization, our first workout was on all the text after we cleaned the data. So for instance, you can see the high frequency text here was high school, school dropout, dropout rate, college dropout. So seeing that this was what we were planning on analyzing, we decided to drop those high frequency words to get a better understanding of what the rest of our text looks like. So for instance, here you can see beauty school. So a lot of students dropped out of beauty school and they would like post hashtag beauty school dropout. And we also did the same for the word cloud for positive and negative tweets. So this, if the positive from our analysis was the tweet positive or negative, and we printed them out. Also, with the negative tweets, we had to also remove cuss words because people weren't very happy. So we tried to be PG-13. So what we also did here was you can, for instance, print out the positive tweets. And with this, you can actually go in and read all the positive tweets, as well as the negative and the neutral. Lastly, I just quickly want to visualize the Twitter analysis count. So here you can see that the majority of our tweets had a positive polarity from our sentiment analysis, and the least was negative. So if I go to our next dashboard, which is from the UN data. So the UN data which we downloaded was the enrollment rates from grade 1 to grade 6 learners over a span of 15 years. So if we plot this distribution, so the observation value is how much students were enrolled in that year, for instance, in grade 1 and grade 2. So here we just did a normal line graph. So you can see, for instance, the blue line is for grade 1, the orange line is for grade 2. And you can see that the observation values, or the amount of students that was enrolled in grade 1, was a lot higher than the students that was enrolled in grade 2. So that indicated that there was some form of dropouts. So what we decided to do was we wanted to investigate that even more. So what we did was we selected groups, and this was now for the enrollment rate from students from 1999 up until 2004. So what this graph actually means is we looked at the students who were enrolled in 1999 as grade 1 students, and we looked how much of them went to grade 2 in 2000, as well as how much of them went to grade 3 in 2002, and it goes on, sorry, until grade 6, which was 2005, I think. And then you can see here that there was a significant drop in the enrollment. So what we also decided to do, it was 2004, apologies. We decided to plot that difference between the years. So from grade 1 to grade 2, there was so much students who weren't registered for grade 2, but who were registered for grade 1. You can also see here that there is a red part of the bar. So what this indicates was that the grade 3 learners, the enrollment for them was larger than the grade 2. So that's why we have that orange bar. And it increases, which means from our graph, we can see that it decreases after that, the students' enrollment. You can obviously do this for all our groups. And then what we also did was we did forecasting. So I'll just, for instance, grab grade 1. So we did we looked at the decomposition, we printed out we looked at the results from summary, and to see how well our model was performing, we were using the ARIMA model. We looked at the diagnostics, and from there, for instance, if I point out for the normal QQ plot, which is the quantile plot, we can say that our model is performing well because the data appears to be roughly in a straight line, as you can see here. And this means that the data is normally distributed, which means there's no bias in the forecasting. That is also, we can also see that in these two graphs there. And then we did prediction from 2010 to 2014. So here you can see the blue line was what was originally observed, and our orange line is what we predicted using the ARIMA. So after that, we also did forecasting. And as you can see here, it kind of creates a line. And at first we thought there was a mistake. But as we went and we looked at the data more clearly, we saw that there is actually a difference in the data, like the number of observation values. It's just that there's so much observation values that's being observed. You can't see all the differences between it so easily from this graph. So that's just our dashboards. Feel free to play around on them. Thank you.
And from our survey data set, we used the Sweetverse library, which generated these visualizations that we can see displayed. And our possible indicators from the analysis, along with the tables displayed, are attendance, studying, being too old or too young, getting a job, and staying with their parents. And we also found out that the learners that stayed with their mothers were more likely to drop out than those that stayed with their fathers and thus focused on the grade ones. And we also found out that things such as chores did not affect the dropout.
5 minutes.
Moving on to the confusion matrix, since our model accuracy is greater than the number of information rate, then our model is performing well. Also, the p-value is less than 0.05, so our accuracy is statistically significant in classifying zeros as zeros and ones as ones. Our capital value is close to 1, so we can classify unbalanced data, pointing out to how well our model is performing. Seeing that the data can be misleading and classifying classification accuracy can also be misleading, we looked at our area under the curve, and since it is closer to 1, we can see that the model is performing well. And even if we were to deploy on new data, it will still classify if students will drop out or not. So these probabilities give us confidence that the model has good accuracy. Then moving on to our scatter plot, these are the probabilities generated from the model that someone will drop out or not drop out. So as we can see that a lot of the learners had a high probability of not dropping out because a lot of it is closer to 1, and there is also a handful of learners with a low probability of not dropping out and also a 0 probability of actually dropping out. On the conclusions, the aim of the project was to use data analytics to describe and identify the possible dropout indicators to improve the learner retention strategy that was originally developed by the government. The aim was established by the project objectives, and the data sets that we had selected helped us in achieving the project objectives. As a result, we were able to conduct a sentiment analysis for the learner dropout to analyzing the grade 1 to grade 6 learner enrollment. We calculated the dropout and the enrollment forecasting. The RIMA model was used it was a good model for predicting and forecasting the learner enrollment. And concerning the CNN binary classification, we were able to identify the possible dropout indicators, and the model also was good at predicting both the learners that would and would not drop out.
From the insights drawn from the datasets used to achieve our objectives, the following recommendations are presented. Positive tweets on dropouts can be used to educate the youth on the impact of the dropout rate on the GDP, unemployment, and crime. Forecasting model can be used by the Department of Basic Education to inform planning, building of schools, and budget resources for improved quality education. The Department of Basic Education can use the CNN module as a monitoring tool at school level. Identified indicators can be used to assist in determining proper school intervention plan for learners who are at risk of dropping out. The Department of Basic Education can use the identified indicators to improve and monitor the impact of the learner retention strategy. This in turn promotes quality education and lifelong learning opportunities, thus appreciating the Sustainable Development Goal. In terms of future works, for the forecasting model, we would like to use a larger data set that spans from grade 1 to 12 to better analyze the enrollment of learners as well as the throughput of grade 12 learners. As we forecast the learner enrollment, learner dropout will be monitored, and this will assist in reducing the high dropout rate that is currently realized from grade 9 to 11. The learner forecasting will also inform teacher forecasting, which will be considered as a future work for this project. The team intends to pilot the CNN model at a local school as a community engagement project to further collect insight on how the model can be used as a dropout monitoring tool. Insight can be shared with the school governing board, who will in turn share the insights with the parents to better support learners with high probability of dropping out. The Center of Teaching, Learning and Program Development at SPU can use the CNN model to formulate the intervention strategy for students. And with that said, I'll thank you.
Thank you. Thank you, Team SPU. Okay, so are there any questions from the judges? We'll start with the judges.
Thank you, SPU. Thank you for understanding the assignment. That was a really enjoyable presentation to listen to. I really enjoyed it. I think mainly because it is similar to what I did for my master's project. So I really enjoyed that. Thank you very much for that. I have two questions. feature selection is very important in machine learning. You have to get it right. So my question is, what features were you looking at for your models, and why did you choose to look at those features? Another question that I have is, having dealt with social media data before myself, I find it very challenging, especially with their data protection issues and privacy issues. What kind of challenges did you face when you had to use Twitter data? Because we know normally that most of the data is not private, so you have to go through many channels for you to be able to use the data. So did you face any challenges in regards to using Twitter data?
Okay. Ma'am, in terms of the features, like initially before we had done the algorithm that selected the features, we looked at the different features that were within the data set, and we tried to see if we did like the group by, we used the group by function to see if there was any analysis that we could find on it. But then we decided that based on the research that we had done, as well as the features that were selected from the router algorithm, we then went with those features to just stick with those, because the features were so much and we weren't really certain, because looking at how the data set was, it's not like an actual data set from like an actual school where it would help us to see based off of how like this particular school performed, we can see, we can cater to like this specific school. So it was just like a survey. So there's also like certain level of uncertainty. Hence we said like the possible features. It's not 100% certain in that aspect. Like some of the features that we had mentioned, those are the ones that we ended up going with.
Okay, and regarding the Twitter data, first getting the API developer's account, you have to go through multiple steps. So that I had to reply from email to email to email, and eventually you get your privacy keys. And regarding like the personal information of the people, we try to censor out that data so that we only work with the data that is like the text data, for instance. We didn't want to have any personal information of the users in the tweets so that we can give them some form of privacy. But regarding any challenges, no, that's the only two challenges you can say. Okay, the first one was a challenge. The second one was just like censoring out their private information, man.
Okay, thank you so much, SPU.
Thank you.
Thank you, SPU. Are there any other questions from the floor?
Sorry, Novella. I just have a question for SPU.
No problem.
Cool. SPU, very well done. Very, very well done. I just have two questions. I noticed that you use sentiment analysis for this one, but I see that it only gives really insight into neutral, positive, and another, I just forget. Is there a reason why you decided not to show all the other moods like anger, like anticipation, so on and so forth? So just a question on that. And then secondly, for your model, what precautions did you take against overfitting for those particular models that you used? Did you guard against overfitting before or while fitting the model? Or did you try and see how you could correct the model from overfitting afterwards? So yeah, those are my two questions. Thanks.
Okay, regarding the Twitter data, we actually did look into getting like the sub-emotions like anger, sad, fear, and happy. But putting it into our dashboard, it was a bit hard. It wasn't hard, but it took very long to analyze the individual tweet. And we decided not to do it. Like if you do look at our code, we did have that portion where we did do the sub-emotions, but we didn't include it in our dashboard. So that's why we only concentrated on those three: positive, negative, and neutral. And that's the reason. Hannah?
Okay, I'm not sure if I understood your question, but it just didn't show like the section of the code in terms of like we could look into the hyperparameters, which is the APH. I'm not sure if I'm pronouncing the word correctly. The batch size as well as the validation split, because like the APH helps with The more you run it, the better you understand the data. And then the batch size, yeah, we used 30, and as well as like the validations, but it also helps with, initially we did like a tuning where we did like the 80-20, but then for the second time we changed it. So I'm not sure if I'm answering the question or not.
Yeah, I think the answer is good enough. Thank you so much.
It's a pleasure, sir.
Thank you, Team SPU. So next we have Unizulu. So Unizulu, if you could share your screen and we can get started. Unizulu, who is here? Bongani. Okay, someone is sharing. All right. So your time, we can't hear you. So I don't know if your mic is on.
Morning.
Hello.
Hello.
Yes, okay. Your time is starting now.
Good morning. Good morning. Team Unizulu, the inevitables were doing school dropout rates. The title of our presentation is No Child Left Behind. That's the team. 50%, half of the students drop out. If you take 100 students from grade 1 and you track them all the way up until grade 12, what we found is that half of them would have dropped out. It is a serious, serious problem. And the problem has only gotten worse since the pandemic. As certain articles have published, certain writings, certain research findings that 500,000 pupils dropped out within the past 16 months. And it is just snowballing out of control. Some studies, the NIDSCRAM study says as much as 750,000 children have dropped out of school during the pandemic. So we felt it was a very pressing need that needs to be addressed. Bongani, can you take over?
Hello, everyone. My name is Bongani Tetilisi. I am a part of the Unizulu Inevitable teams. So from the graph that is displaying, we can see that the dropout rates are more popular among teenage pupils. From the graph, we can see that the largest number of dropouts, they occur between grades 10 and 12. So when we were constructing our project, we largely focused on the teenage age group. Can you please show the next slide? Oh, and then we then analyzed the most common reasons for school dropouts, and these and we found an article that gave us this table, and from this table and other references of data, we constructed a data set where the features were the contributing factors that contributed to teenagers to school learners dropping out, and then we meshed it against the actual number of dropouts reported in schools. Next slide. So the dropout rate, dropping out of school, it is defined as leaving school without completing a given grade. So this problem is a crisis nationally and actually globally, because when pupils do not finish school, they tend to resort to crime, and they end up not contributing to the society. So the government has continuously made efforts to provide quality education to help everybody, but even though the government has made all these efforts, when more pupils are dropping out, they are depriving themselves of getting access to this quality education made available by the government. And the COVID pandemic made matters even more worse. Next slide. I think that's it. Solution.
Hello, everyone. My name is Shablela Shabalala, and I'm here to talk about the solution methodology that we proposed, two of them. Go to the next slide, please. Firstly, we came up with two ideas. Firstly, seeking the dropout rates for the individual provinces, analyzing the dropout rates for the provinces, and also we did a prediction for students in high school, because mostly our data focused on high school level. So we did a prediction for dropout student for probability for a student to drop out. Can you please go to the next slide? So in a dropout insight method, we were trying to search for the dropout rates, trying to understand the dropout rates that is happening, the causes, and being able to predict it. So what we did, we found some data, get data from the general household data. We found some data that talks about dropout on SNAP, survey data, also DBE data, and some other various sources that were providing data about dropout rate in high school level. So we went on try to analyze the we will try to analyze the data by seeing the correlation between the dropout rate and the effects that we observe from the data that we collected. Slide. Slide, please. So on our dropout prediction method, we get data mostly from the NEET claim data, and which was the most useful one. So we went on with the NEET claim data to process and analyze. We were going to analyze the data from there which we will use to build a model using the decision tree algorithm in Google Colab. Next slide, please. So we were having options with the data. We had options with which algorithm are we going to use. So in mind, we have two algorithms. Firstly, we had a logic regression algorithm, and we had the previous one that we saw, the decision tree algorithm. So we had two options that we were going to use, and we were going to choose that. Choosing which algorithm to use was regarding to how data was positioning, how the data looked like when after we have cleaned it and analyzed it. So we use our algorithm to predict we're going to use one of the algorithms to predict if the student is going to drop out or not. Next.
I'm going to share our notebook, and Romani's going to take us through it.
Hello, everyone. This is Mohamed Dutilisi again. Writing the code for our project was one of the most enjoyable experiences we had for this project. So first we had for this project we were creating a machine learning model that took input data and then predicted if an input data of a learner, and then it predicted the likeliness of that learner dropping out of school. So this could help with these predictions. Educators could be notified prior before a student a learner decides to drop out, so they can help them alleviate that decision to drop out of school. Can you, MJ, can you please scroll down? So we followed standard data science procedures. We had our data set. We as my colleague mentioned, that we used the NeedCrem data set to get the information about individuals who were interviewed, and they were asked a series of questions concerning their lifestyles, and most of these individuals that were interviewed were teenagers. So so this information really helped us in training our model to predict how likely a teenage student is likely to drop out of school or finish their grades. Can you please scroll down? So our data, this is how our data set looked like. It was encoded, and it was really difficult. The first difficulty that we had to, since our data set was large, it had about 712 columns, and then we had to choose the appropriate features or the appropriate columns that would be relevant to the data set that we're going to use to train our model. So the first step was to filter the data that we're going to need and use it to train our model. But then the other problem that we had is that the features, most of the features were encoded. Oh, can you please keep scrolling down? Most of the features, the columns were encoded, so it was hard to decipher our data. So the first thing we did, we renamed the columns so that it could be easy to understand which feature we were considering. And then we followed standard procedures to get rid of null values and inappropriate values. And then we also had to change, because our data set had a column indicating the highest grade passed by an interviewing individual. So we had to change that specific column into a column that indicated if the individual had dropped out of school or not. So we just performed a little bit of mathematics, and then we were able to make that conversion. And once our data set was ready for visualization, can you please keep scrolling down? Can you scroll even more down? So these are more standard procedures of removing null values and values that are not valid. So once the data set was ready for visualization, we displayed this heat map graph to show the correlation between individual features that we had in our data sets among themselves to see how they correlated, and this helped us to decipher and decide on which algorithm we're going to use to train our predictive model, classification model. And from the data set, we saw that we had to use a classification model because our main variable, which was the dropout rate, was it had a binary scale. So it was either a student had dropped out or had not dropped out. So we thought then we decided to use the decision tree algorithm to build our model. And once we've built we built our model and we ran it. At first we had challenges that the accuracy of our model was not very good. At first we had a model predicted wrong values with an accuracy of 20%, 28%, but then over time it improved and improved, and then we ended up having the highest value of 68%. So this model could be, as I've said, as mentioned before, it could be used by educators to predict if a student is at the risk of dropping out of school or not, and if they are, they can use this information to help the student. That will be all from me. Thank you.
Okay. We had a lot of challenges with regards to our project. We had strong technical challenges because once we realized the scope of what we wanted to do, we found it difficult to actually implement our desires and our objectives. One of the main issues is that the holy grail of data sets, the SNAP.
Can you just put your presentation on full screen?
Oh, sorry. The holy grail of data sets, the one that is used to determine dropout rates, was delayed in being approved. It was actually only approved today, this morning, about 2 hours ago. And that's the data set that we wanted to use initially. And so because it was delayed in being approved, we first started with collating provincial data, province by province. But then we found that it was not enough to train a model. And this is a challenge. Calculating dropout rates is a challenge. It relies on a very specific key data set. There's also a zero dropout campaign. They talk about this challenge of there not being adequate data that monitors dropout rates. And yeah, so we're actually very passionate about this project, and we are going to continue developing and working on it because we really believe that we could produce something meaningful for the government and policymakers. Sebulala, are you still there?
Yeah, hello everyone again. Initially, state aim was to reduce the school dropout rates by assessing the contributing factors in the dropout in South Africa, dropout rates in South Africa. Analyzing of survey obtained of this project revealed that the school dropout is still an issue as its rate increases, mostly in 2020 due to the pandemic. In conclusion, we would like to build a system that will monitor for the whole South Africa warning the dropout rates, warning about the dropout rates and the factors that will affect that affects the dropout rates, so the government can be able to tackle those issues. Thank you.
Thank you, Team Unizulu. Okay, so are there any questions from the floor? Well, from the judges first, sorry. Are there any questions from the judges? Nolu, sorry?
I think from my side, what was not clear is around their data gathering in terms of what you call this, the sources they've used. I know they mentioned they used DBE data, various other sources, what informed that. And also what comes to mind as we go through these stats around dropout is whether these stats take into consideration students who are taking a break. For example, during COVID, some students didn't come back, but those weren't necessarily, they took a break. Those weren't necessarily drop out. It was just parents saying at this point in time, we're deciding that the child is not going back to school. And I feel when it comes to some of these numbers in terms of dropout rates, particularly in primary and in high school, some of the stats may not necessarily be dropout. It may be what you call these students who are taking a break and classified as dropouts.
Team Unizulu, would you like to comment?
Oh, that's very true. That is a valid concern. And that was one of the issues that we were facing, is that it was very difficult to implement statistical principles with the data sets that we have. We did find a lot of already prepared data of people who had, and studies who had already analyzed data and came up with the dropout rates, but we didn't want to use them. We wanted to go for the data ourselves and come with the conclusions, with the final values that they come up with. And yeah, so we did recognize that challenge, but our data set was very limiting.
Thank you. There is a question. How did you improve the accuracy of the model from 20 to 59%?
Well, we had more data added to our data set at first, because for at our first attempt, when we trained our model, we didn't have as much data as we wanted, as in the number of records, the rows that we have were not enough. So the cramps data was abandoned. So we had another CSV file that we extracted the rows from, and then we concatenated it to the data set that we were currently using. And then we trained our data set again, our model again, and then the accuracy improved.
Okay, Kushat, I hope that has answered your question. Are there any other questions from the floor? Okay, thanks. If not, we will move on to University of Limpopo. So you can stop sharing and we can get you out to share.
Sorry, am I audible?
Yes, we can hear you and we can see your presentation. So the time not now.
Greetings and bienvenue. I hope that you guys are doing well. Our presentation is short, precise, and clear. We're going to be talking about the factors that affect the quality of education. Okay, here we're talking about the background or the overview. As you can see, the link there is where we got our raw data. And then we used Jupyter Notebook and Excel to analyze the data as well as to clean it. But we first had to convert the Excel file, of which we downloaded from that link, to a CSV file because it is what we're comfortable with. And then we took the CSV file, we read it through a Jupyter Notebook so that we can group all the variables. Move on to the next. Yeah. And then this is our objectives or the goals. Yeah. We're going to be focusing on the factors that are affecting the quality of education, as I've mentioned before, of which let me just explain further by saying that we are going to look at the employment rate, the employment rate of South Africa under the certain qualifications that we have studied. And we're going to show the cleaned data set. When I'm talking about the cleaned data set, I'm talking about the data set that we had after using the tools that I've mentioned before on the raw data. And then we're going to explain the analysis of the data set and recommend the solution to the problem that we are currently facing. Matthew, can you continue?
So one of the major factors that is negatively affecting the quality of education is having insufficient education, yet there are many qualified educators out there that are still unemployed. But if you go to schools, especially in rural areas, you will find that there are many overcrowded classes, and it becomes difficult for the learners to participate or engage in those kind of environment. So looking at this analysis of data from the data set that we used, we see that KZN has actually a higher rate of unemployment educators by 40.7%, and followed by Gauteng by 44.81%. Again, we see that the provinces like Northern Cape, Northwest and Western Cape have a smaller rate of unemployment educators of about like 0.07, and then the other one 0.87%, and then Western Cape as well, it's 1.2%. So in this case, if the government decides to create jobs for these educators, they should consider starting with KZN and Gauteng, since the unemployment rate is very high. So I'm going to move to my colleague can continue.
Okay, no, thanks, Matt. Am I audible?
Yes.
Okay, good afternoon, everyone. My name is Tawang. My task, I'll be looking at the overall work experience per gender, as we decided to check if gender could be a factor in the unemployment rate for the qualified educators. So when we look at our data, we can see that we have quite a number of female educators who are unemployed compared to male. But then we can also conclude that this is not much of a big margin to say that there is quite a difference between the two genders. So also, if we can look at the other experience between the two genders, we can see that there is not much difference. So we're able to conclude that gender doesn't play a major role in the work experience between the educators. Moving on to the next slide. Right now, we are going to concentrate on the ethnicity. We're trying to check if the ethnicity can be playing a major role between the unemployed educators. We can see that we have quite a number of African who have at least 1 year experience, and they are still unemployed. We can also see that we have followed by the less than 10 years experience in the African ethnicity. So we can see that given the majority of the Africans in South Africa, we can conclude that this is quite a challenge for us as young people, so that the educators can find jobs after graduating. So when you look at the experience per province, we can still see that the KZN has the majority of unemployment individuals with experience. So from less than 1 year to 5 years, we can see where KZN and Gauteng are the cities with this major problem of qualified and unemployed educators. And then from 5 to 10 years, we can see that Gauteng is the one on top. So like my colleague has already mentioned, should the government try to look further into this problem, KZN and Gauteng should be the provinces that they should focus on. Looking at the top qualifications of those unemployed individuals, we can see that we have quite a number of people who actually obtained the undergrad qualification for teaching, and those who have the PGCE, the method of teaching. So we can see that we do have the skills, we do have the people with equipped skills to guide and educate the future scientists and engineers. But then the problem is that our government somehow is not hiring these people as much as they should. So I think Witumalo will take over from here.
We do recommend that the government should take responsibility, especially on provinces with more qualified unemployed people. This can be done by building more schools and creating more extra classes. They can also subdivide overcrowded classes and give the unemployed qualified teachers opportunities to fill the gap. These unemployed qualified teachers can also consider doing online lessons where they can sell their knowledge online. On the next slide, we conclude that there is a lack of employment in the education field, and the students enrolling in the higher education institutions should try to focus on other courses with high employment demand when registering courses. And the government should take more responsibility regarding unemployment rate in the education field.
We thought that it's nice that we show you how we cleaned the raw data. So the code that you're seeing there, it's actually just a few steps. At first, we extract the file, and then we group it, and then save it. The rest of the cleanup was done through Excellent. Thank you. Thank you very much.
Thank you, Team Limpopo. Are there any questions from the judges first? Okay, and from the general audience. Okay, I don't see any hands. So
Nobubele, if I may.
yes.
Mine is just a general comment to all the presentations that we've received. I'm not sure if there's still any remaining, but my observation is that most of our teams did not look at the solution that they propose as to how will they use that solution to try and resolve the issues or the problems that they identified. So it's just a lesson for maybe in future for the next teams or future teams to specifically look, because we want to create solutions that would be helpful in future for South Africa to deal with real life issues, not to recommend, maybe to say South African government needs to do this and that, but what will the team do to resolve that issue? And that solution should be geared towards that resolution. Thank you.
No, I definitely agree with that, Sistembe. So yeah, I think some of the teams did lack in that area. I don't know if there's any other comments. Okay, so and yeah, just to reiterate, that is the purpose of this DATATHON. We want you to find those open data sets, and we want you to use them to create those solutions to try and solve your problem. I think the teams have taken a step. They've identified the problems. You know, all the problems that they identified were interesting, but they were missing, you know, that next step. But then the hard work is now going to be for the judges to judge and select the winners. So if there is no other further comments, I think we can say that we are done with the presentations, and we would like for the judges to remain behind in the room and yeah, to proceed with the judging of the projects. And to everyone, to the teams, thank you for the presentations, and we will see you at 5:45. So at 5:45, the awards will be held on the CHPC conference link. I will just paste it on the chat. So it will not be streamed in this room. The stream will be on the link that I shared. So you will need to, I think, register and then log in, and you will be able to watch the stream. I'm not exactly sure on which room. Maybe the
It will be on the main room.
But on via the CHPC conference site.
Yes, yes.
Okay, because there's a main DATATHON hall under the DATATHON page, so I'm not sure where that main room.
It's part of the CHPC conference. There is also a main room there. That is where the,
okay.
yes.
Okay, all right. Oh, there's a lobby. Okay, so after you log in, there will be a lobby, and under lobby, you can go to the main hall, I can just share my screen so you can see. Yes.
Can you also please ask the students and mentors, everyone who has attended this session, to join the DRISA track on the CHPC conference? It's currently running right now.
Yes, you can mention it. Maybe you're mentioning it. Okay, all right. No, you can share the links.
Can they please? Yeah, all right. Thanks.
All right. So this is the website. So after you log in, you will see lobby. You click on lobby, then you come to the main hall. So that is where the awards will be held. Currently, right now, we are having a parallel DRISA session where there are a couple of speakers there that are talking about work they're doing as it relates to data management, DRISA, etc. So if you're available now, you can log in and watch that. Later on at 5:45, the proceedings will start for the awards. But right now the judges are going to proceed with the judging. So this session, we can call it closed. And thank you everyone for joining.
Thank you, Novella. Thank you, colleagues.
Thank you everyone. Join the DRISA track. I just sent you a link.
Where did you send the link? Because I just see join DRISA track on the chat.
Yeah, I'm sending it to every student.
Oh,
just pasting it now.
All right, so we can start kicking people out the room.